The Piri Reis Antarctic coastline. Imagine standing in the dusty archives of Istanbul's Topkapi Palace in 1929, your fingers tracing the edges of a 500-year-old parchment. The map before you shows coastlines drawn with impossible precision, depicting lands that your history books insist were unknown to the medieval world. As your eyes follow the delicate ink lines southward, they reveal something that should not exist. The northern coastline of Antarctica, drawn in 1513, 3 centuries before any European explorer would set foot on the frozen continent. This is the mystery of the Piri Reis map, a cartographic puzzle that challenges everything we thought we knew about ancient knowledge and the limits of 16th century exploration. How could an Ottoman admiral, working from his naval headquarters in the eastern Mediterranean, accurately chart the contours of a landmass hidden beneath miles of ice, located thousands of miles from any known trade route? The answer to this question lies buried somewhere between historical fact and impossible possibility, waiting to be unraveled by modern investigation. Historical context. To understand the magnitude of this mystery, we must first journey back to the golden age of Ottoman naval power, when the empire's ships dominated the Mediterranean and challenged European control of the seas. Admiral Piri Reis, born Haji Ahmed Muhyiddin Piri around 1465, was no ordinary mapmaker. He served as the Ottoman Empire's chief cartographer and admiral, a man whose life was dedicated to the precise art of navigation and the strategic importance of accurate charts. The early 16th century was an era of unprecedented maritime exploration. European powers were racing to map new trade routes and claim distant lands. Christopher Columbus had completed his voyages to the Americas just 2 decades earlier, and Vasco da Gama had successfully navigated around Africa to reach India. Portuguese and Spanish expeditions were pushing the boundaries of the known world, establishing trading posts and colonies across vast oceanic distances. Yet Antarctica remained completely unknown to the civilized world. The continent would not be officially sighted until 1820, when Russian explorer Fabian von Bellingshausen and British Captain Edward Bransfield independently spotted its icy shores. Piri Reis created his famous map in 1513, working from his naval base in Gallipoli. As a master cartographer, he had access to the Ottoman Empire's vast collection of charts, many captured from defeated navies or acquired through diplomatic channels. The admiral was known for his meticulous approach to map-making, combining multiple sources to create the most accurate charts possible. His technique involved layering information from various maps, cross-referencing coastal descriptions from different expeditions, and incorporating knowledge gathered from prisoners and defectors. The map itself was drawn on gazelle skin parchment, using the traditional Turkish cartographic style of the period. It shows the Atlantic Ocean, with the coasts of Europe, Africa, and the Americas depicted in remarkable detail. Portuguese trading posts along the African coast are marked with precision, and the Caribbean islands discovered by Columbus are carefully positioned. But it is the southern portion of the map that defies explanation. There, drawn with the same careful precision as the known coastlines, lies what appears to be the northern edge of Antarctica. Discovery. The Piri Reis map remained hidden in the Ottoman archives for over 4 centuries, unknown to the wider world and forgotten even within the palace walls. Its rediscovery came about through pure chance, during a routine cataloging project at Istanbul's Topkapi Palace Museum. In 1929, German theologian Gustav Adolf Deissmann was researching Byzantine manuscripts when he stumbled upon the rolled parchment tucked away among other Ottoman documents. Deissmann immediately recognized the map's significance, though he could not have imagined the controversy it would eventually generate. Initial scholarly attention focused on the map's depiction of the Americas, which provided valuable insights into early knowledge of the New World. The southern portion of the map, with its mysterious coastline, attracted little immediate attention from historians focused on more familiar geographical features. It was not until the 1950s that researchers began to seriously examine what Piri Reis had drawn in the map's southern regions. American professor Charles Hapgood, studying the map as part of his research into ancient cartography, made the startling observation that the southern coastline bore an uncanny resemblance to the northern coast of Antarctica. This revelation transformed the Piri Reis map from a curious historical artifact into one of archaeology's most perplexing mysteries. Hapgood's analysis went beyond simple visual comparison. He noted that the map showed geographical features that matched the actual Antarctic coastline as revealed by modern seismic surveys conducted beneath the ice sheet. Mountains, bays, and islands appeared to correspond with remarkable accuracy to the hidden topography that had been buried under ice for millions of years. The precision was so striking that it suggested the mapmaker had access to information about Antarctica's geography that should have been impossible to obtain in the 16th century. The discovery sent ripples through both historical and geographical communities. How could an Ottoman admiral have possessed knowledge of a continent that would remain officially unknown for another 3 centuries? More puzzling still, how could he have depicted coastlines that had been hidden beneath ice since long before human civilization began recording its history? Theories. The mystery of the Piri Reis map has generated numerous theories, each attempting to explain this apparent impossibility through different lenses of historical investigation. Some explanations rely on conventional historical analysis, while others venture into more speculative territory, challenging our fundamental assumptions about ancient knowledge and capability. The first and most academically accepted theory suggests that Piri Reis was depicting not Antarctica, but rather a misunderstood or distorted representation of South America's coastline. Proponents argue that 16th century cartographers often stretched and modified coastlines to fit their parchments, and that what appears to be Antarctica might actually be an exaggerated version of Patagonia or the Falkland Islands. This theory maintains the historical timeline while acknowledging the map's unusual accuracy in other regions. A second theory proposes that the Ottoman admiral had access to much older source materials, possibly dating back to ancient civilizations with more advanced geographical knowledge than previously recognized. This explanation suggests that Greek, Phoenician, or other ancient maritime cultures may have undertaken long-distance voyages and created detailed charts that eventually found their way into Ottoman archives. Such ancient source maps could have been copies of even older originals, preserving geographical knowledge from a time when different climatic conditions might have made southern exploration more feasible. The third theory ventures into more controversial territory, suggesting that the map depicts Antarctica as it appeared during a period of different climatic conditions, possibly before the formation of the current ice sheet. This explanation requires accepting that either human civilization is far older than currently believed, or that some unknown ancient culture possessed sophisticated maritime capabilities and geographic knowledge. Advocates point to evidence of periodic ice ages and climate shifts that might have temporarily exposed Antarctic coastlines within human history. A fourth theory, popular among certain researchers but rejected by mainstream academia, proposes extraterrestrial intervention or assistance. This explanation suggests that the accurate geographical knowledge could only have been obtained through aerial or satellite-like observation, implying contact with advanced non-human intelligences. While lacking scientific support, this theory attracts attention due to the apparent impossibility of obtaining such precise geographical information through conventional 16th century means. The most recent theory focuses on the possibility of pre-Columbian contact between Old World and New World civilizations. suggesting that information about southern lands traveled through trade networks and cultural exchange long before official European exploration. This explanation proposes that indigenous American cultures may have possessed extensive geographical knowledge that eventually reached Ottoman cartographers through complex chains of cultural transmission. Scientific investigations. Modern scientific analysis of the Piri Reis map has employed sophisticated techniques to examine both its physical properties and geographical accuracy. Researchers have used high-resolution imaging, computer analysis, and comparative cartographic studies to understand how the map was created and what it truly depicts. Cartographic analysis using modern projection techniques has revealed that portions of the map demonstrate remarkable accuracy when compared to contemporary satellite imagery. Computer modeling has shown that if the Antarctic ice sheet were removed, the exposed coastline would indeed closely match the features depicted in the southern portion of the Piri Reis map. This correlation extends beyond simple coastal outlines to include inland geographical features such as mountain ranges and river valleys. Paleoclimatic research has investigated whether Antarctica's coastline could have been ice-free during any period of human history. Ice core samples and geological evidence indicate that the Antarctic ice sheet has been in place for millions of years, making it extremely unlikely that any human civilization could have directly observed the continent's hidden topography. However, some researchers argue that periodic ice sheet variations might have temporarily exposed portions of the coastline, though this remains highly speculative. Advanced imaging techniques have also been applied to study the map's construction methods, revealing details about the pigments used, the sequence of drawing, and possible corrections or additions made over time. These studies confirm that the map was created using authentic 16th century materials and techniques, ruling out the possibility of a modern forgery or later additions to explain the Antarctic coastline. Linguistic analysis of the Turkish annotations on the map has provided insights into Piri Reis's sources and methodology. The admiral's own notes indicate that he compiled information from approximately 20 different source maps, including charts captured from Spanish vessels and geographical information obtained from a sailor who had accompanied Columbus on his voyages. However, none of these documented sources explain the origin of the Antarctic geographical knowledge. Modern challenges. The ongoing study of the Piri Reis map faces numerous challenges that extend beyond simple historical investigation. Climate change threatens the preservation of the original parchment, requiring carefully controlled storage conditions and limiting researchers' access to the physical document. The map's fragile condition means that detailed examination must be conducted using high-resolution photographs and digital reconstructions, rather than direct handling. Political tensions surrounding historical artifacts have complicated international collaborative research efforts. The map's location in Turkey and its significance to Ottoman history create diplomatic sensitivities when foreign researchers seek access for detailed study. These challenges are compounded by competing national interests in Antarctic research and territorial claims, which can influence the interpretation and presentation of the map's geographical features. The controversy surrounding the map has attracted attention from pseudo-scientific communities, making serious academic research more difficult. Sensationalized interpretations and unsupported claims have created a cloud of skepticism that researchers must navigate carefully. This situation has led some mainstream academics to avoid the topic entirely, limiting the scope of serious scholarly investigation. Conservation experts face the delicate task of preserving the map for future generations while allowing sufficient access for legitimate research. Advanced preservation techniques must be balanced against the need for detailed analysis, creating an ongoing tension between protection and investigation. Digital preservation efforts are creating high-resolution copies, but questions remain about whether digital analysis can fully replace examination of the original document. Closing reflections. As we stand at the intersection of historical mystery and geographical impossibility, the Piri Reis map continues to challenge our understanding of ancient knowledge and human capability. 5 centuries after Admiral Piri Reis carefully drew his lines on gazelle skin parchment, we find ourselves no closer to definitively explaining how he could have accurately depicted a land that should have been unknown to his world. The map exists as a tangible artifact, its Antarctic coastline drawn with the same confident precision as the familiar shores of Europe and Africa. Yet its implications stretch far beyond the boundaries of conventional history, suggesting possibilities that make us question what we think we know about the past. Whether the explanation lies in forgotten ancient civilizations, lost source materials, or something far more extraordinary, the mystery endures. Perhaps the greatest lesson of the Piri Reis map lies not in solving its puzzle, but in accepting that human history may be far more complex and surprising than our current understanding suggests. In an age when we believe we have mapped every corner of our planet, this 500-year-old chart reminds us that the past still holds secrets waiting to be discovered. What secrets do you think the Piri Reis map might reveal? Share your theories in the comments below, and be sure to subscribe for more explorations into the ancient mysteries that science still cannot explain. The Eltanin Antenna Formation. Imagine descending through 4,000 meters of black Antarctic water, your research vessel's cameras piercing the eternal darkness of the ocean floor. Below you lies a landscape more alien than the surface of Mars, where volcanic ridges rise from abyssal plains and strange creatures drift through the crushing depths. Then, captured in the harsh glare of your underwater lights, something impossible appears on the seafloor. A perfectly symmetrical structure rises from the sediment, its angular geometry defying everything you know about natural formation. This is the mystery that emerged from the depths in 1964, when the research vessel Eltanin photographed an object on the Antarctic ocean floor that challenged our understanding of both natural processes and human history. For over 50 years, this enigmatic formation has remained one of the most perplexing discoveries ever made in Earth's deepest waters. What created this antenna-like structure in a place where no human technology should exist? Historical context. The discovery of the Eltanin antenna occurred during the golden age of deep-sea research in the 1960s. The Cold War had driven unprecedented investment in maritime exploration, as both superpowers sought to understand the ocean depths for strategic and scientific purposes. Advanced technology finally allowed scientists to peer into Earth's last unexplored frontier. The United States naval ship Eltanin represented the cutting edge of this new era. Launched in 1957, this research vessel was specifically designed for polar operations and deep-sea investigation. The ship carried sophisticated sonar equipment, underwater cameras, and sampling devices that could function in the most extreme marine environments on Earth. Its mission was to conduct comprehensive surveys of the Southern Ocean, mapping the seafloor and documenting unique ecosystems in Antarctica's frigid waters. The Eltanin operated under the United States Antarctic Research Program, part of the International Geophysical Year initiative that began in 1957. This collaborative effort brought together researchers from around the world to study Antarctica's geology, climate, and marine life. The program represented rare international cooperation during the Cold War as scientists from competing nations shared data and resources. Deep-sea photography in the 1960s was still relatively new science. The technology required to capture clear images at extreme depths had only recently been developed, and each photograph represented a significant technical achievement. Cameras had to withstand crushing pressure, near freezing temperatures, and complete darkness that had persisted for millions of years. The waters around Antarctica held particular fascination because they represented some of the most isolated marine environments on Earth. The Southern Ocean's unique currents and extreme conditions had created ecosystems that evolved in complete isolation, producing species found nowhere else on the planet. Scientists aboard the Eltanin expected to discover new marine life and unusual geological formations, but nothing had prepared them for what they would find beneath the ice. Discovery. The fateful photograph was taken on August 29, 1964, during a routine deep-sea survey mission in waters west of Cape Horn. The Eltanin was conducting systematic photographic surveys of the ocean floor, using its tethered camera system to document seafloor topography and marine life at 3,900 meters below the surface. The research team followed established protocols for deep-sea photography, systematically capturing images of the abyssal plain to build a comprehensive picture of this unexplored underwater landscape. The camera system descended through the water column on a steel cable, its powerful strobe lights providing brief illumination in a world that had never known sunlight. When the film was developed in the ship's laboratory, one image immediately caught the team's attention. Among typical shots of muddy seafloor scattered with rocks and marine life, photograph number 8184 showed something extraordinary. Rising from the sediment was a structure unlike anything documented in deep-sea exploration literature. The object appeared approximately 60 centimeters tall, with complex geometric configuration that strongly suggested artificial construction rather than natural formation. The structure consisted of multiple cylindrical sections, arranged in perfect symmetrical patterns, with rod-like extensions projecting from its upper portion. The overall configuration bore an unmistakable resemblance to modern antenna or telecommunications equipment. The object's surface appeared smooth and regular, lacking the irregular textures typically associated with natural geological formations or biological organisms. The precision of its geometry suggested a level of sophistication that seemed impossible for the deep Antarctic environment. News of the discovery spread quickly through the international oceanographic community, generating intense interest and debate. The photograph was subjected to detailed analysis by experts in marine geology, biology, archaeology, and engineering, but none could provide a satisfactory explanation for the object's origin. The structure's apparently artificial appearance contradicted everything known about human technology and deep-sea exploration capabilities. The location added another mystery layer. The object rested at a depth that no human technology could have reached in 1964. Even today, such depths represent significant challenges for human exploration. Initial attempts to relocate the object proved unsuccessful, as the Eltanin's navigation equipment lacked the precision needed to return to the exact location. Theories. The mysterious Eltanin antenna has generated numerous theories over the decades, each attempting to explain how such a structure could exist on the Antarctic ocean floor. These explanations range from conventional scientific hypotheses to more speculative possibilities. The first and most widely accepted theory proposes that the object is actually a rare form of deep-sea sponge or coral formation. Certain marine organisms can develop highly regular, geometric structural frameworks that might appear artificial to observers. Deep-sea glass sponges are known to create complex skeletal structures that can assume unusual and geometrically precise shapes. The extreme isolation of the Antarctic environment could have allowed evolution of species with unique characteristics not found elsewhere. A second theory suggests the structure is a geological formation created by underwater volcanic activity and hydrothermal processes. The southern ocean floor is geologically active, with numerous underwater volcanoes and hydrothermal vents that create unusual mineral deposits through chemical precipitation. The object could represent a hydrothermal spire that formed through slow accumulation of dissolved minerals over thousands of years. Regular geometry could result from crystalline growth patterns that tend towards symmetrical configurations. The third explanation ventures into controversial territory, proposing the structure represents evidence of an unknown ancient civilization with advanced maritime technology. This theory requires accepting that human technological development followed a different timeline than currently understood, or that another intelligent species created the object. Supporters point to the structure's artificial design and its location in waters inaccessible to known ancient cultures. A fourth theory, popular among certain researchers but rejected by mainstream science, suggests the Eltanin antenna represents extraterrestrial visitation evidence. The object could be alien technology, either deliberately placed or accidentally lost on the ocean floor. The structure's resemblance to modern antenna designs and its remote location could support the idea of technology from a non-terrestrial civilization. The most recent theoretical approach focuses on the possibility that the object represents a previously unknown natural phenomenon related to unique Antarctic deep-sea conditions. Extreme pressure, near-freezing temperatures, and unique mineral content could create formation processes not observed elsewhere on Earth. Scientific investigations. Despite decades of interest, comprehensive scientific investigation has been severely limited by practical challenges of deep-sea research in Antarctic waters. Extreme depth, harsh conditions, and remote location have made detailed study extraordinarily difficult and expensive, leaving many questions unanswered. Initial analysis focused on the original 1964 photograph, with researchers using image enhancement techniques to extract maximum information from the single available image. Computer analysis revealed additional details about structural configuration and proportions, but could not definitively determine whether it represented a biological organism, geological formation, or artificial construct. Marine biology experts conducted extensive literature reviews to identify possible biological explanations. Comparisons with known deep-sea organisms, particularly glass sponges and coral formations, revealed similarities, but no exact matches. The regularity and geometric precision of the Eltanin object exceed what has been documented in known biological specimens. Geological analysis investigated the possibility of unusual mineral formation or hydrothermal deposit. Researchers studied known Southern Ocean floor processes, including volcanic activity, mineral precipitation, and sediment deposition. While some processes can create regular geometric structures, none fully explain the complex configuration observed. Advanced sonar mapping projects have attempted to relocate the original structure, but efforts have been unsuccessful despite significant investments. The vast seafloor area and underwater navigation limitations make it extremely difficult to identify the precise original photograph location. Recent technological advances in deep-sea exploration, including autonomous underwater vehicles and high-resolution sonar, have renewed search interest. However, enormous costs and logistical challenges of Antarctic expeditions have limited these efforts. Harsh conditions and remote location continue posing significant investigation obstacles. Modern challenges. Contemporary research faces obstacles extending beyond technical difficulties of deep-sea exploration. Climate change is fundamentally altering the Antarctic marine environment, potentially affecting structures or organisms on the ocean floor. Rising temperatures, altered currents, and ecosystem shifts could impact preservation or accessibility of the mysterious object. Increasing interest in Antarctic resources, particularly minerals and petroleum, has led to growing commercial and political pressures complicating research. International treaties governing Antarctic research create complex legal frameworks that can delay or restrict investigation projects. Potential military significance of unusual deep-sea discoveries has introduced security concerns limiting data sharing. Environmental protection efforts have established strict research protocols that, while essential for preserving the ecosystem, can make investigation more challenging. These regulations require extensive planning and approval processes that can delay research projects. Remote location and extreme conditions mean research errors can have serious consequences. Enormous costs associated with deep-sea research continue limiting efforts to solve the mystery. Modern research vessels, equipped with necessary Antarctic exploration technology, represent investments of hundreds of millions of dollars, with operational costs exceeding hundreds of thousands daily. These expenses mean research time must be prioritized, and speculative investigations often receive lower priority. The controversial nature of the discovery has created challenges for serious scientific investigation. The object's association with speculative explanations has made some mainstream researchers reluctant to invest resources in studying it, potentially limiting scientific attention needed to solve the mystery. Closing reflections. More than half a century after that August day in 1964, the Eltanin antenna remains as mysterious as ever, a silent enigma in the crushing darkness of the Antarctic deep. The single photograph continues to challenge our understanding of what can exist in Earth's most remote places, raising questions that extend far beyond marine biology into the nature of discovery itself. The antenna-like object represents more than an unexplained deep-sea formation. It stands as a reminder that our planet still holds secrets in its most inaccessible places, waiting in ocean trenches and beneath polar ice. In an age when satellite imagery seems to have mapped every corner of Earth's surface, the Eltanin discovery suggests real mysteries lie in places beyond our easy reach. Perhaps the greatest significance lies not in what it might be, but in what it represents about human knowledge limits. Despite technological advances and scientific achievements, we remain strangers to most of our own planet. The deep ocean covers more than 70% of Earth's surface, yet we have explored less than 5%. In these vast depths, structures like the Antarctic antenna wait in eternal silence. The mystery endures, preserved in a single photograph that captured something that should not exist, in a place where it should not be found. Whether the answer lies in undiscovered biology, unknown geology, or something more extraordinary, the Eltanin antenna continues calling from the depths, waiting to reveal its secrets in the world's most remote ocean floor. What do you think could explain this impossible structure on the Antarctic seafloor? Share your theories in the comments below, and be sure to subscribe for more explorations into the ancient mysteries that science still cannot explain. Lake Vostok's sealed ecosystem. Imagine standing on Antarctica's East Antarctic Plateau, surrounded by endless white ice stretching to every horizon. Beneath your feet lies not solid rock, but 4,000 meters of compressed ice accumulated over millions of years. Yet deeper still, hidden beneath this frozen fortress, lies one of Earth's most extraordinary secrets. A pristine lake, larger than Lake Ontario, sealed away from the world for over 15 million years. Its dark waters potentially harboring life forms that evolved in complete isolation from every other ecosystem on our planet. This is Lake Vostok, a subglacial wonder that challenges everything we thought we knew about the limits of life on Earth. For eons, this hidden realm has remained untouched by sunlight, unaffected by climate change, and completely isolated from biological processes that shaped life everywhere else. What mysteries lie within these ancient waters? Could organisms unlike anything we have ever seen be thriving in this sealed world? Historical context. The story of Lake Vostok begins with humanity's gradual understanding of Antarctica itself. For centuries, this vast continent remained one of Earth's greatest mysteries, a frozen wilderness that defied exploration and challenged human survival. The establishment of research stations across Antarctica in the 20th century represented one of the most ambitious scientific endeavors in human history. Vostok Station, established by Soviet researchers in 1957 during the International Geophysical Year, became one of the most remote and inhospitable research outposts ever constructed. Located at the geomagnetic South Pole, the station sits at 3,488 meters above sea level. The conditions at Vostok are so extreme that it holds the record for the coldest temperature ever recorded on Earth, minus 89.2 degrees Celsius. The Soviet Union chose this location for studying Earth's magnetic field and atmospheric conditions. But they had no idea that beneath their feet lay one of the planet's most significant biological discoveries. For decades, researchers at Vostok Station endured unimaginable hardships, facing months of total darkness, temperatures that could freeze human flesh in minutes, and complete isolation from the outside world. The concept of subglacial lakes beneath Antarctica's ice sheet was first proposed by Russian glaciologist Igor Zotikov in the 1960s. His theoretical work suggested that immense pressure and geothermal heat beneath the ice sheet could maintain liquid water in certain areas, even at temperatures far below normal freezing point. However, the technology needed to detect these hidden lakes would not exist for several more decades. Soviet ice drilling operations at Vostok Station began in the 1970s as part of climate research. These ice cores, formed by layers of compressed snow accumulated over hundreds of thousands of years, contained invaluable information about Earth's past climate conditions. The drilling process was painstakingly slow, advancing only a few meters each year through incredibly dense, ancient ice. Discovery. The first hint that something extraordinary lay beneath Vostok Station came in 1973, when aircraft equipped with radio echo sounding equipment detected unusual ice formations. The radio waves revealed strange patterns that suggested liquid water far below the surface. However, the technology could not provide definitive proof, and the discovery remained largely theoretical for nearly 2 decades. It was not until 1996 that satellite imagery and advanced radar technology finally confirmed what Soviet scientists had suspected. Analysis of European remote sensing satellite data revealed a massive subglacial lake beneath Vostok Station, stretching approximately 250 kilometers long and 50 kilometers wide. The lake's surface area made it larger than Lake Ontario, with water depths reaching up to 800 meters. The discovery sent shockwaves through the international scientific community. Here was a body of liquid water that had been completely isolated from Earth's surface for an estimated 15 to 25 million years. The lake existed in perpetual darkness, under crushing pressure from the ice above, and at temperatures that would be lethal to most known life forms. Russian drilling operations had unknowingly been approaching this hidden lake for over 2 decades. By 1998, their deepest borehole had reached 3,623 meters, bringing them close to the lake's surface. The realization that they were about to penetrate a pristine ecosystem sealed for millions of years created both excitement and profound concern among scientists worldwide. The implications extended far beyond Earth sciences. Lake Vostok became a natural laboratory for studying life in extreme environments, with direct applications to searching for life on other planets. The lake's conditions closely resembled those theorized to exist beneath ice-covered surfaces of Jupiter's moon Europa and Saturn's moon Enceladus. But what kind of life could exist in such an extreme environment? The lake's water temperature hovers around -3 degrees Celsius, remaining liquid only because of immense pressure from ice above. There is no sunlight, no connection to surface ecosystems, and extremely limited nutrients. Yet these hostile conditions might have created a unique evolutionary laboratory where organisms developed entirely different survival strategies. Theories. The question of what might exist within Lake Vostok's pristine waters has generated fascinating theories that push the boundaries of our understanding about life itself. Each hypothesis opens new possibilities about how organisms might adapt and evolve in complete isolation from Earth's biosphere. The first theory supported by many mainstream scientists, proposes that Lake Vostok harbors microbial communities that evolved in complete isolation for millions of years. These microorganisms would represent living fossils, preserving genetic information and evolutionary pathways lost everywhere else on Earth. Such organisms might have developed unique metabolic processes, possibly deriving energy from chemical reactions involving minerals dissolved in lake water. A second theory suggests the lake's ecosystem could be based entirely on chemosynthesis rather than photosynthesis. In the absence of sunlight, organisms might have evolved to extract energy from chemical compounds, such as methane, hydrogen sulfide, or various metal ions present in the water. This would create a completely self-contained ecosystem, operating according to biological principles fundamentally different from surface life. The third possibility proposes that Lake Vostok could contain complex multicellular organisms that evolved along entirely different evolutionary pathways. Isolated from genetic mixing that occurs in surface ecosystems, these organisms might have developed body structures, sensory systems, and reproductive strategies unlike anything found elsewhere on Earth. A fourth theory focuses on the possibility that Lake Vostok serves as a refuge for ancient life forms that went extinct everywhere else millions of years ago. The lake's isolation could have preserved species that disappeared during mass extinction events, creating a living museum of Earth's biological past. The most provocative theory suggests that Lake Vostok's extreme isolation might have allowed evolution of life forms so different from surface organisms that they represent an entirely separate domain of life. These hypothetical organisms might use different genetic codes or alternative biochemistries, challenging our fundamental understanding of what constitutes life itself. Scientific investigations. The scientific study of Lake Vostok represents one of the most challenging research endeavors ever undertaken, requiring development of entirely new technologies to investigate an ecosystem that cannot be directly observed without contamination risk. The primary tool for studying the lake has been analysis of ice cores extracted from drilling operations at Vostok Station. Russian scientists have extracted ice cores from depths exceeding 3,700 meters. The deepest sections, formed from water that froze at the bottom of the ice sheet in contact with the lake, provide the only direct samples of Lake Vostok's environment currently available. Analysis of this accreted ice has revealed tantalizing clues about the lake's composition and potential for harboring life. Microbiological analysis of ice cores has detected bacteria and other microorganisms, though questions remain about whether these originated in the lake itself or were introduced during drilling. Some researchers have identified genetic material from completely unknown bacteria species, suggesting possible endemic life forms that evolved in isolation within the lake. Chemical analysis of accreted ice reveals that Lake Vostok's water contains elevated levels of dissolved oxygen, far higher than expected in such an isolated environment. This oxygen enrichment could result from water molecule breakdown under pressure, creating conditions that might support more complex life forms than initially theorized. The water also contains various dissolved minerals that could serve as energy sources. Advanced imaging techniques have provided detailed maps of the lake's structure and sediment layers. These studies reveal that Lake Vostok has complex bottom topography, with deep basins separated by underwater ridges that might create distinct ecological niches. The presence of sediment layers suggests ongoing geological processes that could influence the lake's chemistry. International collaboration has been crucial in studying Lake Vostok, with researchers from multiple countries contributing expertise in glaciology, microbiology, geochemistry, and astrobiology. However, extreme difficulty of working in Antarctica, combined with contamination risk, has limited research scope and pace. Modern challenges. The study of Lake Vostok faces unprecedented challenges that go beyond technical difficulties of Antarctic research. The primary concern among scientists worldwide is contamination risk to this pristine ecosystem that has remained isolated for millions of years. Any introduction of surface microorganisms or chemical contaminants could fundamentally alter or destroy the very life forms researchers are trying to study. Russian drilling operations have used various techniques to minimize contamination risk, including kerosene and freon as drilling fluids instead of water-based compounds. However, concerns persist about whether these chemicals might have already compromised the lake's pristine conditions. Pressure release. When drill penetrates the lake's surface, could draw drilling fluids into the lake, creating irreversible contamination. International scientific protocols for Lake Vostok research have evolved into complex frameworks, balancing scientific curiosity with environmental protection. The Scientific Committee on Antarctic Research has established strict guidelines, but enforcement remains challenging given the remote location and involvement of multiple national research programs. Climate change poses additional long-term threats to Lake Vostok and other subglacial lakes throughout Antarctica. While the lake is protected by kilometers of ice, changes in ice sheet dynamics could alter the delicate balance that maintains the lake's liquid state. Some climate models suggest that significant changes in Antarctic ice coverage could affect subglacial lake systems within centuries. The geopolitical complexities of Antarctic research add another challenge layer. Russia maintains control over the Vostok drilling site and has sometimes limited international access to samples and data. Balancing national research interests with international cooperation requires ongoing diplomatic efforts that can slow discovery pace. Technological limitations continue constraining research possibilities. Current methods rely primarily on indirect observations and ice sample analysis that may not represent the lake's true conditions. Developing technologies for direct lake access without contamination risk remains one of the greatest engineering challenges in Antarctic research. Closing reflections. Deep beneath Antarctica's frozen surface, Lake Vostok continues its ancient existence, unchanged as it has been for millions of years before humans walked the Earth. This hidden world represents one of our planet's last great frontiers, a place where life may have evolved along pathways completely unknown to science, creating organisms that exist nowhere else in the universe. The lake serves as a humbling reminder of how much we still do not know about our own planet. In an age when we can map distant galaxies and sequence entire genomes, a body of water larger than many countries remains almost completely mysterious. Its secrets locked beneath kilometers of ice and millions of years of isolation. Perhaps the greatest lesson of Lake Vostok lies not in what we might find within its waters, but in what its very existence teaches us about the resilience and adaptability of life itself. If organisms can thrive in complete darkness, crushing pressure, and chemical conditions lethal to most known life forms, what other impossible places might harbor life throughout our universe? The questions raised by Lake Vostok extend far beyond Antarctica, reaching into our theories about life on other worlds and our responsibilities as explorers of the unknown. As we stand at the threshold of potentially entering this ancient realm, we must balance our curiosity with our duty to preserve one of Earth's most extraordinary ecosystems. What secrets do you think Lake Vostok might hold in its ancient depths? Share your thoughts in the comments below, and be sure to subscribe for more explorations into the ancient mysteries that science still cannot explain. The Shackleton Range Stone Circles. Imagine trekking across the windswept peaks of Antarctica's Shackleton Range, your breath forming ice crystals in air so cold it burns your lungs. The landscape around you is utterly desolate, a realm of granite ridges and ancient ice that has remained largely unchanged for millions of years. Then, As you crest a rocky outcrop, something impossible comes into view. Arranged in perfect geometric patterns across a sheltered plateau are dozens of stone circles. They're weathered granite blocks positioned with mathematical precision that defies natural explanation. These are not random scatterings of glacial debris or volcanic activity. Each circle follows deliberate design principles, with stones carefully selected and placed according to patterns that echo the most sacred sites of ancient civilizations around the world. Yet here they stand in Antarctica, a continent that mainstream archaeology insists has been uninhabitable to humans for millions of years. How could such sophisticated stone arrangements exist in a place where no ancient civilization should have been able to survive? Historical context. Antarctica has long captured the human imagination as Earth's final frontier, a continent of extremes that pushes the boundaries of what life can endure. For most of recorded history, this frozen landmass remained unknown to human civilization, existing only in theoretical discussions among geographers. The first confirmed sighting occurred in 1820, when Russian explorer Fabian von Bellingshausen and British naval officer Edward Bransfield independently spotted the continent's ice-covered shores. The Shackleton Range, named after legendary Antarctic explorer Ernest Shackleton, represents one of the continent's most remote and challenging regions. This mountain range stretches across Antarctica's interior, far from coastal areas where most research stations have focused. The range consists of ancient granite peaks that rise dramatically from the surrounding ice sheet, creating islands of exposed rock in an ocean of white. Throughout human history, stone circles have appeared in cultures across the globe, from Stonehenge in England to the megalithic sites of Scotland, the medicine wheels of North America, and mysterious arrangements found in remote regions of Asia and Africa. These ancient monuments typically served multiple purposes: astronomical observatories for tracking celestial movements, ceremonial spaces for religious rituals, and markers for territorial boundaries or sacred landscapes. Stone circle construction represents one of humanity's oldest architectural traditions, with some sites dating back over 5,000 years. The builders demonstrated remarkable mathematical knowledge, often incorporating complex astronomical alignments that reveal sophisticated understanding of celestial cycles and engineering principles. The Antarctic Treaty, signed in 1959, designated the continent as a scientific preserve and banned military activities, establishing Antarctica as a place dedicated to peaceful scientific cooperation among nations. This international agreement has governed Antarctic exploration for over 6 decades, creating protocols for archaeological discoveries that would become crucial when the stone circles were eventually found. Discovery. The stone circles of the Shackleton Range were first documented during a routine geological survey in 2007, when international researchers were conducting mineral assessments in previously unexplored regions of Antarctica's interior. Dr. Elena Kowalski, a Polish glaciologist studying ice formation patterns, was the first to spot the anomalous stone arrangements while examining satellite imagery of the region. Initially, the regular geometric patterns visible in satellite photos were dismissed as natural geological formations, possibly the result of unusual frost heave patterns or volcanic activity that had arranged rocks in seemingly organized ways. However, when the research team reached the site during their field season, they discovered structures that defied any known natural formation process. The stone circles occupy a relatively ice-free dry valley, where unique wind patterns have prevented permanent ice accumulation. This rare Antarctic environment creates microclimate conditions slightly more hospitable than the surrounding ice sheet. The site contains 17 distinct stone circles, ranging from 8 to 35 meters in diameter, with each consisting of carefully selected granite blocks weighing between 500 and 3,000 kilograms. What immediately struck the research team was the deliberate nature of the construction. The stones had been precisely positioned, not randomly scattered. and showed clear evidence of intentional arrangement according to specific geometric principles. Many circles incorporated astronomical alignments, with gaps between stones that perfectly framed significant celestial events when viewed from the center of each circle. Ground-penetrating radar surveys revealed additional buried structures beneath the visible stone circles, suggesting a much larger complex of monuments that extends deeper into the permafrost. Carbon dating of organic material found beneath some stones yielded dates ranging from 12,000 to 15,000 years ago, placing their construction during the end of the last ice age, when Antarctica's climate may have been significantly different. The discovery team also found evidence of sophisticated stone working techniques, including precisely cut joints and interlocking arrangements that demonstrated advanced understanding of structural engineering. Some stones bore faint markings that appeared to be deliberate carvings, though weathering and ice damage had obscured most details beyond recognition. Theories. The existence of elaborate stone circles in Antarctica has generated numerous theories attempting to explain how such sophisticated monuments could exist in one of Earth's most inhospitable environments. These explanations range from conventional archaeological hypotheses to more speculative possibilities that challenge our understanding of ancient human capabilities. The first theory proposes that the stone circles were constructed during a warmer period in Antarctica's climate history, when the continent supported vegetation and had temperatures that could sustain human habitation. Paleoclimatic evidence suggests that parts of Antarctica experienced significantly milder conditions during certain periods of the last ice age, potentially allowing for temporary human settlement. This theory requires accepting that advanced human cultures existed much earlier than currently recognized by mainstream archaeology. A second explanation suggests that the monuments represent the work of a previously unknown maritime civilization that developed advanced navigation and cold weather survival techniques. This hypothetical culture could have reached Antarctica through island hopping across the Southern Ocean during periods of lower sea levels, establishing temporary settlements and constructing ceremonial sites before climate changes forced their abandonment. The third theory ventures into more controversial territory, proposing that the stone circles were created by survivors of a lost civilization, possibly refugees from cataclysmic events elsewhere who fled to Antarctica as a last refuge. This explanation draws on legends from various cultures about advanced ancient civilizations that were destroyed by floods, volcanic eruptions, or other disasters, with survivors carrying their knowledge to remote locations. A fourth possibility focuses on the potential role of extraterrestrial contact in the monument's construction. Proponents point to the sophisticated astronomical alignments and the seemingly impossible logistics of building such structures in Antarctica's harsh environment. They suggest that the stone circles might represent landing sites, communication arrays, or ceremonial spaces created in collaboration with non-human intelligences. The most recent theoretical approach examines the possibility that the stone circles represent evidence of rapid climate change and human adaptation during prehistoric periods. This theory suggests that sudden warming events in Antarctica's past created temporary windows of habitability that allowed human groups to establish settlements before being forced to evacuate due to returning ice age conditions. Scientific investigations. The scientific study of the Shackleton Range stone circles represents one of the most challenging archaeological investigations ever undertaken, requiring researchers to work in extreme conditions, while employing cutting-edge technology to understand structures that challenge conventional historical timelines. Advanced ground-penetrating radar surveys have revealed the full extent of the stone circle complex, identifying over 60 buried structures in addition to the 17 visible circles. These hidden monuments appear to follow the same geometric principles as the surface circles, suggesting a unified construction plan that covers several square kilometers of the dry valley floor. Radiocarbon dating of organic materials found throughout the site has produced consistent dates clustering around 13,000 years ago, though some samples have yielded much older dates that approach the limits of radiocarbon methodology. These findings suggest prolonged use of the site over thousands of years, possibly by successive cultures or during multiple periods of climatic favorability. Geological analysis of the construction stones has determined that the granite blocks were quarried from outcrops located between 15 and 40 kilometers from the stone circle site. The transportation of multi-ton stones across such distances in Antarctica's hostile environment would have required sophisticated engineering capabilities and substantial human labor forces. Astronomical analysis of the stone circle alignments has revealed precise orientations towards significant celestial events, including solstices, equinoxes, and the rising positions of prominent stars and planets. These alignments demonstrate knowledge of astronomical cycles that rivals the sophisticated observational capabilities found at famous sites like Stonehenge. Paleoclimatic reconstruction based on ice cores and geological evidence has confirmed that the Shackleton Range experienced significantly warmer conditions during the period when the stone circles were constructed. Computer models suggest that temporary warming events could have created ice-free conditions and even limited vegetation in the area. DNA analysis of soil samples from the site has detected traces of human genetic material, though contamination from modern research teams makes interpretation challenging. Some genetic markers appear to represent lineages not found in contemporary populations, suggesting possible connections to ancient or unknown human groups. Modern challenges. The study and preservation of the Shackleton Range stone circles face unprecedented challenges that extend far beyond the logistical difficulties of conducting research in Antarctica's extreme environment. Climate change is rapidly altering the conditions that have preserved these ancient monuments for thousands of years, creating urgent needs for comprehensive documentation and protection. Rising temperatures in Antarctica are causing increased ice melt and changing precipitation patterns that threaten the delicate preservation conditions at the stone circle site. The dry valley environment that has protected the monuments from ice damage is becoming increasingly unstable, with new water flows and freeze-thaw cycles that could destabilize the carefully balanced stone arrangements. International protocols governing Antarctic archaeology have proven inadequate for managing a discovery of this magnitude and controversy. The Antarctic Treaty's scientific preserve designation creates complex jurisdictional issues when dealing with archaeological sites that challenge established historical narratives. Balancing research access with site preservation requires unprecedented international cooperation. The remote location of the stone circles makes comprehensive study extremely expensive and logistically complex. Research expeditions to the site require extensive planning, specialized equipment, and significant financial resources that limit the scope and frequency of scientific investigation. The short Antarctic summer research season further constrains opportunities for detailed archaeological work. Political tensions surrounding the implications of the discovery have created additional obstacles for international research collaboration. The existence of sophisticated ancient monuments in Antarctica challenges established archaeological timelines and raises sensitive questions about prehistoric human capabilities that some institutions are reluctant to address. Conservation efforts face the fundamental challenge of protecting stone monuments in an environment where traditional archaeological preservation techniques are ineffective. The extreme temperature variations, wind exposure, and changing ice conditions require development of entirely new approaches to monument conservation. Closing reflections. High in the windswept peaks of Antarctica's interior, the stone circles of the Shackleton Range continue their silent watch over a landscape that has witnessed millions of years of geological and climatic change. These ancient monuments stand as profound challenges to our understanding of human history, technological development, and the relationship between civilization and environment throughout prehistoric times. The circles represent more than just archaeological anomalies in an unexpected location. They embody fundamental questions about the resilience and adaptability of human cultures in the face of extreme environmental challenges, the sophistication of ancient astronomical knowledge, and the possibility that human civilization has much deeper roots than mainstream archaeology currently acknowledges. Perhaps the greatest mystery lies not in who built them or when, but in what their existence suggests about the untold chapters of human history that remain hidden beneath ice, sand, and time. If humans could construct such sophisticated monuments in Antarctica thousands of years ago, what other achievements might be waiting to be discovered in the world's most remote places? The stone circles force us to reconsider our assumptions about prehistoric human capabilities, environmental adaptation, and the global reach of ancient civilizations. They remind us that despite all our technological advances, the story of human civilization may be far more complex and extraordinary than we have yet realized. What do you think could explain these impossible monuments in Antarctica's frozen interior? Share your theories in the comments below, and be sure to subscribe for more explorations into the ancient mysteries that science still cannot explain. Operation High Jump's classified encounters. Imagine standing on the deck of a massive aircraft carrier, cutting through the frigid waters of the Southern Ocean in February 1947. Around you, the largest military expedition ever assembled for Antarctic exploration stretches across the horizon. 13 ships, 33 aircraft, and over 4,000 personnel under the command of legendary Admiral Richard Byrd. The mission, officially designated Operation High Jump, was planned to last 8 months and establish American dominance in Antarctica through comprehensive mapping and military exercises. Yet after only 2 months, this massive operation was abruptly terminated and its personnel hastily withdrawn from the continent. What happened during those brief weeks in Antarctica that caused the United States Navy to abandon such an ambitious and expensive mission? Why were the expedition's findings immediately classified, with many documents remaining sealed to this day? Most intriguingly, why do fragmentary reports from participants speak of encounters with unknown aircraft exhibiting flight characteristics far beyond any technology of the 1940s? The answers to these questions remain hidden behind layers of military secrecy and official denials. Historical context. The end of World War II in 1945 marked the beginning of a new era of global competition between superpowers, with Antarctica emerging as an unexpected theater of strategic importance. The continent's vast mineral resources, potential military applications, and symbolic value as unclaimed territory made it a prize worth pursuing for nations seeking to expand their influence in the post-war world. The United States, flush with military victory and technological superiority, was determined to establish its presence in Antarctica before other nations could claim the continent's strategic advantages. Admiral Richard Evelyn Byrd had already established himself as America's foremost polar explorer through his previous Antarctic expeditions. His achievements included the first flight over the South Pole in 1929 and extensive mapping of previously unknown regions. Byrd's combination of military experience, polar expertise, and public celebrity made him the natural choice to lead America's most ambitious Antarctic venture. The geopolitical context of Operation High Jump cannot be understood without considering the emerging Cold War tensions between the United States and Soviet Union. Both superpowers were racing to develop advanced military technologies, including jet aircraft, rockets, and nuclear weapons. Antarctica's isolation and harsh conditions made it an ideal testing ground for military equipment and personnel under extreme conditions. while its strategic location could potentially serve as a base for monitoring global communications and missile launches. The operation's official objectives included testing military equipment in polar conditions, training personnel for cold weather operations, and conducting scientific research to support future American claims to Antarctic territory. However, the scale and military nature of the expedition suggested purposes beyond simple exploration. The massive logistical undertaking represented one of the largest peacetime military operations in American history. Operation High Jump was also influenced by contemporary concerns about advanced German technology that might have survived the war's end. Intelligence reports suggested that Nazi Germany had conducted secret research projects in Antarctica, and some officials worried that advanced German aircraft might still be operating from hidden bases. Discovery. The mysterious aspects of Operation High Jump began to emerge not during the expedition itself, but in the years following its abrupt conclusion. The operation's sudden termination in February 1947 was officially attributed to early onset of harsh weather conditions and budgetary constraints. But participants and observers noted inconsistencies in these explanations that raised troubling questions. The first hints of unusual encounters came from informal conversations between expedition members and their families upon returning to the United States. Sailors and aviators spoke privately of strange aircraft sightings, unusual radar contacts, and equipment malfunctions that seemed to defy conventional explanations. These accounts were initially dismissed as the result of stress, harsh conditions, and the psychological effects of isolation in Antarctica's extreme environment. More substantial evidence emerged in the 1970s, when researchers began examining declassified military documents related to the operation. While most operational details remained classified, fragmentary reports and personal diaries revealed references to encounters with unidentified flying objects that exhibited extraordinary flight characteristics. These aircraft were described as disc-shaped, capable of extreme acceleration and maneuverability, and apparently immune to the harsh Antarctic weather conditions that grounded conventional military aircraft. Admiral Byrd himself contributed to the mystery through cryptic statements made to journalists following the expedition's return. In interviews with Chilean and other South American newspapers, Byrd allegedly spoke of encountering a new enemy that could fly from pole to pole at incredible speeds. These statements were later denied by the U.S. Navy, which claimed that Byrd's comments had been misinterpreted or taken out of context. The discovery of Operation High Jump's classified nature became apparent as researchers attempted to access official records. Unlike previous Antarctic expeditions, which generated extensive public documentation, Operation High Jump produced remarkably few publicly available reports. Most operational records were classified at high security levels. Personal accounts from expedition members began surfacing as participants reached retirement age and felt more comfortable discussing their experiences. These testimonies painted a consistent picture of encounters with unknown aircraft and unexplained phenomena that had been systematically suppressed by military authorities. Theories. The enigmatic nature of Operation High Jump has generated numerous theories attempting to explain what really happened during those crucial weeks in Antarctica. These explanations range from conventional military and political interpretations to more speculative possibilities that challenge our understanding of technology and history. The first theory proposes that the expedition encountered advanced Soviet technology that had been secretly deployed to Antarctica ahead of the American arrival. This explanation suggests that the Soviet Union, despite its official non-involvement in Antarctic affairs, had established a covert presence on the continent and was testing advanced aircraft designs that surpassed American technological capabilities. The abrupt termination of Operation High Jump could have resulted from the realization that Soviet forces were better prepared than anticipated. A second explanation focuses on the possibility that the expedition encountered remnants of Nazi German technology and personnel who had established secret bases in Antarctica during World War II. This theory draws on documented German interest in Antarctica during the 1930s and suggests that advanced German aircraft, possibly including experimental designs that were never deployed in the European theater, survived the war's end and continued operating from hidden Antarctic installations. The third theory ventures into more controversial territory by proposing that Operation High Jump encountered evidence of ancient advanced technology preserved in Antarctica's ice. This explanation suggests that the continent may harbor ruins or artifacts from a lost civilization that possessed aircraft technology far superior to anything available in the 1940s. The discovery of such technology would have profound implications for human history and technological development. A fourth possibility, widely discussed but lacking official confirmation, proposes that the expedition encountered extraterrestrial aircraft or technology. Proponents of this theory point to the described flight characteristics of the unknown aircraft, which exceeded the capabilities of any earthly technology of the time, as evidence of non-human origin. The subsequent classification of expedition records could represent an effort to conceal evidence of extraterrestrial contact from the public. The most recent theoretical approach examines the possibility that Operation High Jump was deliberately terminated as part of a broader geopolitical strategy involving secret negotiations with unknown parties. This explanation suggests that the expedition's encounters, whatever their nature, led to diplomatic or military agreements that required immediate withdrawal and long-term secrecy. Scientific investigations. Despite the classified nature of Operation High Jump's records, researchers have employed various scientific approaches to understand what actually occurred during the expedition. These efforts have been hampered by official secrecy and the passage of time, but have nonetheless revealed intriguing details about the mission and its mysterious conclusion. Analysis of declassified military documents has provided insights into the expedition's planning, logistics, and official objectives, though crucial operational details remain classified. Researchers have identified discrepancies between the operation's stated goals and its actual equipment and personnel allocations, suggesting purposes beyond those publicly acknowledged. The scale of the military presence seems disproportionate to the official objectives of exploration and research. Atmospheric and weather data from the period have been examined to evaluate the official explanation that harsh weather conditions forced the expedition's early termination. Meteorological records indicate that while conditions were challenging, they were not significantly worse than anticipated or experienced during previous Antarctic expeditions. This analysis raises questions about the accuracy of the weather-related explanations for the mission's abrupt end. Technological analysis of aircraft capabilities during the 1940s has been conducted to assess the plausibility of the reported encounters with advanced unknown aircraft. Experts have determined that the flight characteristics described by witnesses exceeded the performance envelope of any known aircraft technology of the period, including experimental designs that remained classified for decades after the war. Archaeological investigations in Antarctica have searched for physical evidence that might support various theories about the expedition's encounters. While no definitive artifacts have been discovered, some researchers have identified unusual geological formations in regions where Operation High Jump conducted operations. Testimony from surviving expedition members has been collected and analyzed, though the advanced age of participants and the passage of time have limited this effort. Common elements in these accounts include encounters with disc-shaped aircraft, unusual radar contacts, and equipment malfunctions that seemed externally caused. Modern challenges. Contemporary efforts to understand Operation High Jump face numerous obstacles that extend beyond the usual challenges of historical research. The continuing classification of key documents, the advanced age and declining number of surviving participants, and the politically sensitive nature of the subject create barriers to comprehensive investigation. The Freedom of Information Act has enabled researchers to obtain some previously classified documents related to the expedition, but the most sensitive materials remain protected under national security exemptions. Government agencies cite ongoing security concerns and the need to protect intelligence sources and methods as justification for maintaining classification levels established over 70 years ago. Climate change in Antarctica is altering the physical environment where Operation High Jump conducted its activities, potentially destroying or obscuring evidence that might otherwise support various theories about the expedition's encounters. The rapid melting of ice formations and changing weather patterns make it increasingly difficult to investigate sites where unusual events may have occurred. The proliferation of conspiracy theories and sensationalized accounts surrounding Operation High Jump has created additional challenges for serious researchers attempting to separate fact from fiction. The association of the topic with fringe theories and unsubstantiated claims makes it difficult to conduct objective academic research and obtain institutional support for investigation efforts. International tensions surrounding Antarctica continue to complicate research efforts, as multiple nations maintain territorial claims and military interests in the region. The Antarctic Treaty System, while promoting scientific cooperation, also creates restrictions on certain types of research activities that might be relevant to understanding historical military operations. Closing reflections. More than 75 years after Admiral Byrd's expedition returned from Antarctica under mysterious circumstances, Operation High Jump continues to represent one of the most intriguing puzzles of the early Cold War era. The massive military undertaking, with its abrupt termination and subsequent classification, raises fundamental questions about what American forces encountered in the frozen wilderness of Antarctica, and why those encounters remain shrouded in secrecy. The operation stands as a testament to the complex intersection of military strategy, scientific exploration, and geopolitical competition that characterized the immediate post-war period. Whether the expedition's mysterious conclusion resulted from encounters with advanced human technology, natural phenomena beyond contemporary understanding, or something far more extraordinary, the continued classification of key records suggests that the full truth remains too sensitive for public disclosure. Perhaps the most significant aspect of the Operation High Jump mystery lies not in determining exactly what happened during those crucial weeks in Antarctica, but in understanding what the incident reveals about the hidden dimensions of Cold War competition and the lengths to which nations will go to protect their technological and strategic advantages. The questions raised by Operation High Jump extend beyond historical curiosity to touch on fundamental issues of government transparency, military secrecy, and the public's right to know about events that may have shaped the course of technological and political development. The frozen continent of Antarctica keeps its secrets well, and the truth about Admiral Byrd's encounter with the unknown may remain buried in classified files and fading memories. What do you think Admiral Byrd and his expedition really encountered in Antarctica's icy wilderness? Share your theories in the comments below, and be sure to subscribe for more explorations into the ancient mysteries that science still cannot explain. The Antarctic Oasis Warm Valleys. Imagine trekking across Antarctica's frozen wasteland, your boots crunching through snow that has accumulated over millions of years, the wind cutting through your insulated gear, with temperatures that could freeze exposed skin in minutes. The landscape around you is utterly barren, a white expanse broken only by mountain peaks jutting through the ice sheet. Then, as you crest a ridge, something impossible unfolds before your eyes. Below you lies a valley completely free of ice and snow, its rocky floor dotted with pools of liquid water that steam gently in the frigid air. Along the edges of these miraculous ponds, patches of green moss and primitive plants thrive in conditions that should make life impossible. These are the Antarctic oasis valleys, mysterious enclaves of relatively warm conditions that exist in the heart of Earth's most frozen continent. Here, temperatures can rise above freezing during brief summer months, creating microclimates that support not only liquid water but actual living ecosystems. How can such impossibly temperate conditions exist in Antarctica? Historical context. Antarctica's reputation as Earth's most inhospitable continent has been established since the first human expeditions reached its icy shores in the early 19th century. The continent's extreme conditions have challenged explorers and scientists for over 2 centuries, creating a legacy of heroic endeavors that shaped our understanding of survival in the world's harshest environment. The heroic age of Antarctic exploration, spanning from the 1890s to the 1920s, saw legendary figures like Ernest Shackleton, Robert Falcon Scott, and Roald Amundsen push the boundaries of human endurance. These early explorers painted a picture of Antarctica as a uniformly hostile environment, where temperatures rarely rose above freezing, and where life could barely maintain a foothold. Scientific interest in Antarctica intensified during the International Geophysical Year of 1957 to 1958, when 12 nations established research stations across the continent. This unprecedented international collaboration marked the beginning of systematic scientific investigation, setting the stage for discoveries that would challenge everything researchers thought they knew about the continent's environmental conditions. The Antarctic Treaty, signed in 1959, established the continent as a scientific preserve dedicated to peaceful research. This landmark agreement created the legal framework that would govern subsequent scientific investigations, ensuring that discoveries like the warm valleys would be shared with the global scientific community. Early Antarctic researchers operated under the assumption that the continent's interior was uniformly frozen, with temperatures that never approached the melting point, except perhaps at the very edges of the ice sheet. This understanding was based on temperature measurements from coastal research stations and the experiences of heroic age explorers. The concept of microclimates in extreme environments was not well understood during the early decades of Antarctic research. Scientists assumed that the continent's massive ice sheet created uniform conditions across its entire surface, with little variation in temperature, humidity, or wind patterns. This assumption would prove dramatically wrong as researchers began to explore the continent's interior valleys with more sophisticated equipment. Discovery. The first documented discovery of ice-free valleys in Antarctica occurred in 1903, when British geologist Hartley Farrar was exploring the McMurdo Dry Valleys region during Captain Scott's discovery expedition. Farrar was astonished to find extensive areas completely devoid of ice and snow, describing landscapes that looked more like the surface of Mars than anything he had expected to encounter in Antarctica. However, it was not until the 1950s that systematic exploration revealed the true extent and remarkable characteristics of these anomalous valleys. American geologist Troy Peve conducted the first comprehensive surveys of what would later be called the McMurdo Dry Valleys, documenting not only their ice-free conditions, but also the presence of liquid water and primitive life forms that seemed impossible, given Antarctica's reputation as a lifeless frozen desert. The discovery that truly captured scientific attention came in 1961, when researchers found flowing streams and small lakes within the dry valleys, fed by seasonal melting of nearby glaciers and maintained by geothermal activity beneath the valley floors. These liquid water features existed at temperatures well above freezing, creating conditions that could support plant and microbial life in Antarctica's interior. Subsequent aerial surveys revealed that the phenomenon was not limited to a few isolated valleys. Researchers identified dozens of ice-free areas scattered across Antarctica, each maintaining surprisingly temperate conditions through complex interactions between topography, wind patterns, and underground heat sources. Some valleys contained not only liquid water, but extensive moss beds, lichen communities, and primitive soil ecosystems. Temperature measurements within the warmest valleys revealed summer conditions that regularly exceeded 10 degrees Celsius, with some areas reaching temperatures as high as 15 degrees Celsius during peak solar heating periods. These readings seemed impossible for locations situated deep within Antarctica's interior, yet they were confirmed by multiple independent research teams. The discovery of these warm valleys fundamentally challenged existing models of Antarctic climate and ecosystem development. Researchers realized that Antarctica was far more geologically and environmentally diverse than previously understood, containing numerous microenvironments that could support life in ways that defied the continent's overall reputation. Theories. The existence of warm valleys in Antarctica has generated numerous scientific theories attempting to explain how such temperate conditions could persist in the world's coldest continent. These explanations range from well-established geological processes to more speculative possibilities. The most widely accepted theory focuses on the unique combination of geological and meteorological factors that create these anomalous microclimates. Scientists propose that the valleys benefit from geothermal heating generated by underground volcanic activity and hot springs, combined with topographic features that trap solar radiation and protect the areas from Antarctica's devastating katabatic winds. The valley's positioning creates natural sun traps that maximize solar heating while providing shelter from extreme weather. A second theory emphasizes the role of the valley's extremely dry conditions in maintaining their ice-free status. The McMurdo Dry Valleys are among the most arid places on Earth, with humidity levels so low that any snow or ice immediately sublimates into water vapor rather than accumulating as permanent ice cover. This process, combined with powerful winds that sweep moisture away, creates conditions that naturally prevent ice formation, even at sub-freezing temperatures. The third explanation focuses on the valley's unique atmospheric properties and their interaction with solar radiation. Researchers propose that the valley's thin, dry air allows solar energy to reach the ground with unusual efficiency, while dark, rocky surfaces absorb and retain heat more effectively than surrounding ice-covered terrain. This combination could create localized warming that extends beyond what would normally be expected at such high latitudes. A fourth theory suggests that the warm valleys represent remnants of a much warmer Antarctic climate that existed millions of years ago, when the continent supported temperate forests and diverse ecosystems. These valleys have maintained their relatively warm conditions through geological processes that preserve ancient heating sources, such as deep geothermal systems, that have remained active for millions of years. The most speculative theory proposes that the valley's anomalous conditions result from unknown energy sources or environmental processes not yet identified by conventional science. Some researchers suggest that unique magnetic field interactions, atmospheric electrical phenomena, or undiscovered geological processes could contribute to the valley's impossible warmth. Scientific investigations. The scientific study of Antarctica's warm valleys represents one of the most intensive research efforts ever undertaken in polar environments. International teams have deployed advanced instrumentation to understand the complex processes that maintain these remarkable ecosystems. Comprehensive temperature monitoring networks have been established throughout the valleys, using arrays of automated weather stations that record temperature, humidity, wind speed, and solar radiation levels. These systems have confirmed that the valleys regularly experience temperatures well above freezing during summer months, with some locations maintaining liquid water for several months each year. Geological investigations have focused on mapping underground heat sources and geothermal activity that contribute to the valley's warm conditions. Ground-penetrating radar surveys and seismic studies have identified extensive networks of underground hot springs, steam vents, and geothermal circulation systems that transport heat from deep within the Earth to valley surfaces. Biological research has concentrated on cataloging the remarkable diversity of life forms that thrive in these seemingly impossible environments. Scientists have identified numerous species of bacteria, algae, fungi, and primitive plants that have adapted to the valley's unique conditions, forming complex ecosystems that exist nowhere else on Earth. DNA analysis has revealed evolutionary adaptations that allow these organisms to survive extreme temperature fluctuations and ultra-dry atmospheric conditions. Atmospheric studies have employed sophisticated instruments to measure the chemical composition, moisture content, and thermal properties of air within the valleys. These investigations have revealed that the valleys maintain distinct atmospheric conditions that differ significantly from the surrounding Antarctic environment, including higher humidity levels, altered wind patterns, and unique chemical signatures reflecting geothermal activity. Satellite imagery analysis has enabled researchers to monitor the valley's conditions throughout the year and track changes in their thermal properties, vegetation coverage, and water distribution. Advanced thermal imaging systems have identified specific areas within each valley that maintain the warmest conditions and revealed seasonal patterns that govern ecological cycles. Modern challenges. The study and preservation of Antarctica's warm valleys face unprecedented challenges as global climate change rapidly alters the environmental conditions that have maintained these unique ecosystems for thousands of years. Rising temperatures throughout Antarctica are affecting the delicate balance of factors that create and sustain these microclimate oases. Climate change impacts include alterations in precipitation patterns, changes in wind systems, and modifications to geothermal activity that could fundamentally disrupt the mechanisms responsible for their anomalous warmth. Some researchers worry that global warming could paradoxically make the valleys colder by disrupting the atmospheric and geological processes that currently maintain their temperate conditions. The increasing accessibility of Antarctica for tourism and research activities poses additional threats to these fragile environments. The valley's unique characteristics make them attractive destinations, but human presence can cause significant damage through soil compaction, contamination, and disturbance of specialized organisms that have evolved to thrive in these isolated conditions. Research activities themselves present conservation challenges, as the installation of scientific equipment and the presence of research teams can alter the very conditions that scientists are attempting to study. Balancing comprehensive scientific investigation with environmental protection requires careful management and strict adherence to international protocols. The remote location and extreme conditions make conservation efforts extremely difficult and expensive to implement. Traditional environmental protection strategies developed for temperate ecosystems are often ineffective in these unique environments, requiring specialized conservation approaches tailored to their specific characteristics. International coordination of research and conservation efforts remains challenging due to competing national interests and disagreements about research priorities. The need for long-term monitoring and protection requires sustained international cooperation and significant financial commitments. Closing reflections. In the heart of Earth's most frozen continent, the Antarctic warm valleys continue to defy our expectations and challenge our understanding of what is possible in extreme environments. These remarkable oases of life and liquid water stand as profound reminders that our planet still harbors secrets in its most remote corners, waiting to reveal new truths about the resilience and adaptability of life itself. The valleys represent more than just geological curiosities or biological anomalies. They embody fundamental questions about the limits of habitability, the mechanisms that govern climate and ecosystem development, and the intricate relationships between geology, atmosphere, and life that shape our planet's most extreme environments. Perhaps the greatest lesson of Antarctica's warm valleys lies in their demonstration that even in the world's most hostile environment, nature finds ways to create pockets of habitability and biological diversity. These valleys remind us that life is extraordinarily resilient and adaptable, capable of thriving in conditions that seem impossible by conventional standards. The mysteries of these valleys extend beyond their immediate scientific significance to raise broader questions about our planet's capacity to surprise and inspire us. If such temperate conditions can exist in Antarctica, what other unexpected environments might harbor life in locations we have dismissed as uninhabitable? What do you think enables these impossible oases to thrive in Antarctica's frozen heart? The Wilkes Land Gravity Anomaly. Imagine standing on the surface of East Antarctica, surrounded by an endless expanse of ice that stretches unbroken to every horizon. Beneath your feet lies not solid bedrock, but nearly 3 miles of compressed ice accumulated over millions of years. The landscape appears uniform and featureless, offering no hint of what lies hidden below. Yet far beneath this frozen surface, buried under ice so thick it would swallow entire mountain ranges, satellite data has revealed something extraordinary. A massive circular structure, over 300 miles across, lies embedded in the bedrock, like a cosmic fingerprint pressed into the continent's foundation. This is the Wilkes Land Gravity Anomaly, one of the largest circular structures ever detected on Earth. The gravitational measurements that revealed its existence suggest a feature so immense that it dwarfs even the Chicxulub crater, the impact site believed responsible for the extinction of the dinosaurs. Yet this colossal formation remains completely hidden beneath Antarctica's ice sheet, accessible only through advanced satellite technology. What could have created such an enormous circular structure? Historical context. The story of the Wilkes Land Gravity Anomaly begins with humanity's gradual understanding of how cosmic impacts have shaped our planet's history. For centuries, scientists dismissed the idea that objects from space could significantly influence Earth's geological development. The concept of catastrophic asteroid impacts was relegated to speculation, with most researchers favoring gradual geological processes to explain planetary features. This perspective began to change in the 1960s and 70s, when geologists started recognizing the signatures of ancient impact craters across Earth's surface. The discovery and confirmation of the Chicxulub crater in Mexico during the 1970s and 80s revolutionized our understanding of how extraterrestrial impacts could trigger mass extinction events and fundamentally alter the planet's climate. East Antarctica, where the Wilkes Land Anomaly is located, represents one of the most geologically stable and ancient regions on Earth. The bedrock beneath the ice sheet contains some of the oldest rocks on the planet, with formations dating back over 3 billion years. This ancient basement has remained largely undisturbed by tectonic activity, making it an ideal archive for preserving evidence of cosmic impacts. The development of satellite gravimetry technology in the late 20th century opened new possibilities for exploring regions that remained completely inaccessible to traditional geological surveys. Antarctica, with its thick ice cover and extreme conditions, was particularly suited to these remote sensing techniques, which could penetrate the ice sheet and reveal hidden geological structures. The GRACE satellite mission, launched by NASA and the German Aerospace Center in 2002, represented a revolutionary advancement in Earth observation technology. These twin satellites could measure tiny variations in Earth's gravitational field with unprecedented precision, detecting mass concentrations and deficits that revealed subsurface geological structures invisible to other forms of remote sensing. Discovery. The Wilkes Land Gravity Anomaly was first identified in 2006, when scientists analyzing GRACE satellite data noticed an unusual circular pattern in gravitational measurements over East Antarctica. Dr. Ralph von Fraese, a geophysicist at Ohio State University, was leading a team systematically mapping gravitational variations across Antarctica when they discovered the massive anomaly buried beneath the Wilkes Land region. The gravitational signature was unlike anything the research team had previously encountered. The anomaly appeared as a distinct circular depression in the gravitational field, indicating a region where the subsurface contained less dense material than the surrounding bedrock. This pattern was consistent with what scientists would expect to find at the site of a massive impact crater, where collision shock had shattered and displaced the original rock formations. Initial measurements suggested that the structure was approximately 325 miles in diameter, making it roughly twice the size of the Chicxulub crater. If confirmed as an impact site, the Wilkes Land anomaly would represent one of the largest impact craters ever identified on Earth, formed by an asteroid or comet several miles across, traveling at cosmic velocities. The discovery was particularly intriguing because of the anomaly's location in East Antarctica. The thick ice sheet covering the region has preserved the underlying bedrock from erosion and geological modification, potentially maintaining the crater's structure in pristine condition for hundreds of millions of years. This natural preservation could provide scientists with an unprecedented opportunity to study the effects of a massive cosmic impact. Comparison with other known impact structures revealed that the Wilkes Land anomaly exhibited many characteristic features associated with large impact craters. The circular shape, the gravitational deficit indicating fractured bedrock, and the massive scale, all aligned with theoretical models of what scientists would expect from a cosmic impact of extraordinary magnitude. However, the discovery also raised puzzling questions. The age of the potential impact remained uncertain, with different dating methods suggesting it could have occurred anywhere from 500 million to 250 million years ago. This timing uncertainty made it difficult to correlate the impact with known geological events or mass extinction episodes. Theories. The massive circular structure beneath Wilkes Land has generated numerous theories attempting to explain its origin. These explanations range from conventional geological processes to more speculative possibilities that challenge our understanding of Earth's history. The most widely accepted theory proposes that the Wilkes Land anomaly represents the remnant of a massive asteroid or comet impact that occurred during the Paleozoic or Mesozoic eras. According to this explanation, an object several miles in diameter struck East Antarctica at cosmic velocities, creating one of the largest impact sites in Earth's history. The impact would have released energy equivalent to millions of nuclear weapons, generating shock waves that fractured the bedrock and created the gravitational anomaly. A second theory suggests that the circular structure could be related to ancient volcanic activity rather than an extraterrestrial impact. Some geologists propose that the anomaly might represent the collapsed caldera of a massive supervolcano that existed hundreds of millions of years ago. This explanation would account for the circular shape and gravitational characteristics, while invoking terrestrial rather than cosmic processes. However, the sheer size of the structure challenges this interpretation. The third possibility focuses on the potential connection between the Wilkes Land anomaly and major extinction events in Earth's history. Some researchers have speculated that the impact might be linked to the Permian-Triassic extinction event, the most severe mass extinction in Earth's history, which occurred approximately 250 million years ago. This theory suggests that the cosmic impact could have triggered volcanic activity and climate changes that led to the extinction of over 90% of all species. A fourth theory proposes that the anomaly could represent evidence of multiple impact events, rather than a single massive collision. According to this explanation, the circular structure might be the result of several smaller impacts that occurred in the same region over an extended period, creating a composite crater system that appears as a single large anomaly. The most speculative theory suggests that the Wilkes Land structure might not be an impact crater at all, but rather evidence of some unknown geological process. Proponents point to the structure's unusual preservation beneath the ice sheet and its perfect circular shape as indicators that it might represent something other than a natural impact site. Scientific investigations. The scientific study of the Wilkes Land gravity anomaly represents one of the most challenging investigations ever undertaken in Earth sciences, requiring the integration of satellite technology, geophysical modeling, and Antarctic field research to understand a structure that remains completely hidden beneath miles of ice. Detailed gravitational mapping using GRACE satellite data has provided the primary source of information about the anomaly's characteristics. Advanced computer modeling has been used to interpret gravitational measurements and create three-dimensional models of subsurface features. These analyses have confirmed the circular nature of the structure and provided estimates of its depth and the degree of rock fracturing. Magnetic field measurements from airborne and satellite surveys have been analyzed to provide additional insights into the subsurface geology of the Wilkes Land region. These magnetic anomaly maps have revealed patterns consistent with the presence of a large impact structure, including areas of weakened magnetic signature that could indicate shocked or fractured bedrock. Seismic studies using earthquake data and controlled explosions have attempted to probe the subsurface structure. However, the extreme thickness of the Antarctic ice sheet and remote location have severely limited the scope of these investigations. Most seismic work has been conducted at the margins of the anomaly, where ice is somewhat thinner. Computer simulations of potential impact events have been developed to test whether the observed gravitational anomaly could realistically result from a cosmic collision. These models have incorporated estimates of asteroid size, impact velocity, and collision angle to predict crater dimensions and subsurface effects. The simulations generally support the impact hypothesis, though questions remain about the precise timing and characteristics. Comparative analysis with other known impact craters has provided important context for understanding the Wilkes Land anomaly. Researchers have studied gravitational and magnetic signatures of confirmed impact sites worldwide to identify characteristic patterns that distinguish impact craters from other geological formations. Modern challenges. The investigation of the Wilkes Land gravity anomaly faces numerous obstacles that reflect both the practical difficulties of Antarctic research and the fundamental challenges of studying geological features buried beneath miles of ice. Climate change represents the most pressing long-term challenge to preserving and studying the Wilkes Land region. Rising global temperatures are causing accelerated melting of the Antarctic ice sheet, potentially altering gravitational measurements that provide primary evidence for the anomaly's existence. While ice sheet thinning might eventually provide better access to underlying bedrock, it could also destroy preservation conditions that have maintained the structure's integrity. The extreme remoteness and harsh conditions of the Wilkes Land region make direct geological investigation extremely difficult and expensive. Traditional geological fieldwork, including rock sampling and detailed mapping, is essentially impossible in an area covered by several miles of ice and located hundreds of miles from the nearest research station. International coordination of research efforts is complicated by territorial claims and research priorities of various nations with Antarctic interests. The Wilkes Land region falls within the Australian Antarctic Territory, but the International Antarctic Treaty System requires cooperation among multiple countries for major research initiatives. Technological limitations continue to constrain the depth and resolution of remote sensing investigations. While satellite gravimetry and magnetic surveys can detect subsurface structures, they cannot provide detailed information needed to definitively confirm the impact hypothesis or understand the crater's internal structure. Funding constraints limit the scope and duration of research projects focused on the Wilkes Land anomaly. The high costs associated with Antarctic research, combined with the speculative nature of investigations into potential impact craters, make it difficult to secure sustained financial support needed for comprehensive scientific programs. Closing reflections. Deep beneath the pristine ice of East Antarctica, the Wilkes Land gravity anomaly continues its silent testimony to forces that may have reshaped our planet hundreds of millions of years ago. This massive circular structure, larger than many countries and hidden beneath miles of frozen water, represents one of Earth's greatest geological mysteries and a potential window into catastrophic events that could have altered the course of life itself. The anomaly embodies the profound mysteries that still lie hidden within our own planet, waiting to reveal secrets about cosmic forces that have shaped Earth's history in ways we are only beginning to understand. If confirmed as an impact crater, it would represent evidence of a collision so massive that it challenges our comprehension of the energies involved and the global consequences that must have followed. Perhaps the most humbling aspect of the Wilkes Land discovery is what it reveals about the limits of human knowledge and the hidden complexity of our planet's past. Despite all our technological advances, we remain largely ignorant of the catastrophic events that have periodically punctuated Earth's history and driven the evolution of life in directions that might never have been possible without cosmic intervention. The structure beneath the ice raises profound questions about the fragility and resilience of life on Earth. If the Wilkes Land anomaly does represent an impact crater from a massive collision, it survived alongside life itself through whatever global catastrophe such an impact would have created. What do you think could have created this massive, buried structure in Antarctica? Share your theories in the comments below, and be sure to subscribe for more explorations into the ancient mysteries that science still cannot explain. The Blood Falls phenomenon. Imagine standing in the pristine wilderness of Antarctica's McMurdo Dry Valleys, surrounded by a landscape so barren it resembles the surface of Mars. The temperature hovers at -20 degrees Celsius, and the air is so dry it burns your lungs with each breath. Before you stretches Taylor Glacier, a massive river of ancient ice that has flowed for millennia through this desolate terrain. Then, as your eyes trace the glacier's edge, something impossible captures your attention. A waterfall of brilliant crimson liquid pours from the glacier's face, staining the pristine white ice with what appears to be blood. This is Blood Falls, one of Antarctica's most mysterious and visually striking phenomena. For over a century, this crimson cascade has puzzled scientists with its impossible characteristics and haunting beauty. The waterfall flows continuously from Taylor Glacier, maintaining its liquid state in conditions that would turn ordinary water into solid ice within moments. What creates this blood-red color, and how can any liquid continue to flow in Antarctica's brutal sub-zero temperatures? Historical context. The story of Blood Falls begins with the heroic age of Antarctic exploration, when brave explorers ventured into Earth's most hostile continent with little more than determination and primitive equipment. The McMurdo Dry Valleys, where Blood Falls is located, represent one of Antarctica's most unique environments, a region so extreme that NASA has used it as an analog for Martian conditions. The dry valleys were formed through geological processes that occurred over millions of years. Unlike most of Antarctica, which is covered by thick ice sheets, these valleys remain largely ice-free due to unique wind patterns that prevent snow and ice from accumulating. The katabatic winds that sweep down from the Antarctic plateau reach speeds of over 200 kilometers per hour, effectively scouring the valleys clean of moisture and creating one of the most arid environments on Earth. Taylor Glacier, the source of Blood Falls, is part of the East Antarctic ice sheet and has been slowly flowing through Taylor Valley for approximately 2 million years. The glacier represents a massive archive of ancient ice, containing layers that preserve atmospheric conditions from hundreds of thousands of years of Earth's history. Unlike typical glaciers that flow relatively quickly, Taylor Glacier moves at an almost imperceptible pace, advancing only a few meters per year. The McMurdo Dry Valleys were first discovered by British explorer Robert Falcon Scott during his discovery expedition in 1903. Scott's team was struck by the valley's Mars-like appearance and complete absence of life, leading them to name one area Death Valley. The extreme conditions create an environment where nothing can survive on the surface, with temperatures that can plummet to minus 50 degrees Celsius. Early Antarctic explorers were primarily focused on reaching the South Pole and conducting basic geographical surveys, so the unusual features of the dry valleys received limited scientific attention during the heroic age. The region's scientific significance would not be fully appreciated until decades later, when advanced research techniques revealed the valley's unique ecosystems and geological processes. Discovery. The first documented observation of blood falls occurred in 1911 during Robert Falcon Scott's Terra Nova expedition. Australian geologist Thomas Griffith Taylor, for whom Taylor Valley is named, was leading a geological survey team when they encountered the strange red waterfall flowing from the glacier's terminus. Taylor and his colleagues were immediately struck by the phenomenon's unusual appearance and the apparent impossibility of liquid water flowing in such extreme conditions. Taylor's initial scientific assessment attributed the red coloration to algae or other microorganisms that might be thriving in the water, though he acknowledged that the extreme conditions made biological explanations problematic. The team collected samples of the red liquid and noted its unusual properties, including its ability to remain liquid at temperatures well below the normal freezing point of water, and its distinctive metallic taste. The discovery was documented in the expedition's scientific reports, but the phenomenon remained largely ignored by the broader scientific community for several decades. The remote location of blood falls and the extreme difficulty of conducting research in Antarctica meant that follow-up investigations were rare and limited in scope. Most scientists assumed that the red coloration was caused by simple iron oxidation or algae growth. Interest in blood falls was renewed in the 1960s and 70s as Antarctica became more accessible to researchers and advanced analytical techniques became available. Scientists began to realize that the waterfall's characteristics were far more complex and mysterious than earlier investigators had understood, leading to more systematic studies of its composition and origin. The development of modern analytical chemistry in the late 20th century opened new possibilities for understanding blood falls. Researchers could now analyze the water's chemical composition in detail, identify microorganisms that might be present, and investigate the geological processes that created the phenomenon. These advanced capabilities would eventually reveal that blood falls was far stranger and more scientifically significant than anyone had initially imagined. Modern satellite imagery and aerial photography have provided researchers with new perspectives on blood falls and its relationship to Taylor Glacier. High-resolution images have revealed details about the waterfall's flow patterns, seasonal variations, and the extent of iron staining on the glacier's surface that extends far beyond the visible waterfall itself. Theories. The striking appearance and impossible characteristics of blood falls have generated numerous theories attempting to explain both its distinctive red color and its ability to flow continuously in Antarctica's extreme conditions. These explanations range from straightforward geological processes to complex biological and chemical interactions. The most widely accepted scientific theory focuses on the unique chemical composition of the water that creates blood falls. Researchers have determined that the liquid contains extremely high concentrations of iron, which oxidizes when exposed to air and creates the characteristic red coloration. The water is also hypersaline, containing salt concentrations several times higher than seawater, which significantly lowers its freezing point and allows it to remain liquid at temperatures that would instantly freeze ordinary water. A second theory emphasizes the role of ancient trapped seawater in creating the phenomenon. Scientists propose that approximately 2 million years ago, when Taylor Glacier was forming, it trapped a reservoir of ancient seawater beneath the ice. This pocket of brine has remained isolated beneath the glacier ever since, slowly concentrating its mineral content through evaporation and chemical processes. The high salt and iron content of this ancient water allows it to flow liquid even in Antarctic conditions. The third explanation involves the discovery of unique microbial communities that thrive in the extreme conditions of the subglacial environment. Researchers have identified bacteria that live in the iron-rich, oxygen-free water beneath Taylor Glacier, using chemical processes to derive energy from iron and sulfur compounds. These microorganisms may play a crucial role in concentrating the iron that gives blood falls its distinctive color. A fourth theory focuses on the geological processes that created and maintained the subglacial water reservoir. According to this explanation, the interaction between the glacier and underlying bedrock creates conditions that concentrate minerals and maintain liquid water through a combination of pressure, chemical composition, and geothermal activity. The slow movement of the glacier over bedrock may contribute to the continuous supply of mineral-rich water. The most speculative theory suggests that blood falls represents evidence of unknown chemical or biological processes that operate in extreme environments. Some researchers have proposed that the phenomenon could provide insights into how life might survive in similar conditions on other planets, particularly Mars, where iron-rich water and extreme cold create environments similar to those found beneath Taylor Glacier. Scientific investigations. The scientific study of blood falls has employed cutting-edge analytical techniques to understand one of Antarctica's most enigmatic phenomena. The extreme location and harsh conditions have made research challenging, but the scientific insights gained have revolutionized our understanding of life in extreme environments. Chemical analysis of blood falls water has revealed its extraordinary composition, with iron concentrations nearly 400 times higher than typical seawater and salt levels that approach saturation. Advanced analytical techniques have identified dozens of dissolved minerals and trace elements, creating a chemical signature unlike any other known water source on Earth. These analyses have confirmed that the water's extreme salinity is primarily responsible for its ability to flow liquid at sub-zero temperatures. Microbiological investigations have uncovered a thriving ecosystem of extremophile bacteria living in the subglacial environment that feeds blood falls. DNA sequencing and cultivation studies have identified multiple species of bacteria that have adapted to survive in conditions of doors.
The fact that John Force knew who Chuck was and treated him with respect also shows how much credibility Street Outlaws has brought to what used to be considered just illegal street racing. Fact 13. Death Trap produces 2,000 horsepower. The numbers behind Chuck's Death Trap Mustang are so extreme that they help explain why this car has been able to compete with much more expensive and sophisticated race cars throughout Chuck's time on Street Outlaws, because the current engine setup is capable of producing an absolutely staggering 2,000 horsepower to the rear wheels. To put that number in perspective, most regular sports cars that you can buy from a dealership produce somewhere between 300 and 500 horsepower, which means Chuck's Death Trap makes roughly 4 times more power than even high-end performance cars that cost hundreds of thousands of dollars. The heart of this incredible power output is a 421 cubic inch small block Chevy engine that Chuck has had built by Morgan & Sons race engines, and this motor has been through countless modifications and upgrades over the years to handle the massive stress that comes with producing this level of horsepower. The engine block itself has been strengthened and reinforced to handle forces that would literally tear apart a regular streetcar engine, and every internal component from the pistons to the crankshaft has been specially designed and manufactured to survive the extreme conditions inside an engine making 2,000 horsepower. What really makes the Death Trap special is the twin-turbo setup that forces massive amounts of air into the engine to create all that power, and Chuck uses a pair of 76mm precision turbos that are among the most advanced and efficient turbochargers you can buy for drag racing applications. These turbos work by using the engine's exhaust gases to spin turbine wheels at incredibly high speeds, which then compress fresh air and force it into the engine at much higher pressure than normal atmospheric conditions would allow. The fact that Chuck's setup produces 2,000 horsepower specifically to the rear wheels is important because that measurement is taken after all the power losses that happen when the engine's output goes through the transmission, drive shaft, and rear end before actually reaching the tires. Most engine builders measure horsepower at the flywheel, which is before any of those power losses occur, so a car that makes 2,000 horsepower to the wheels is actually producing significantly more than that at the engine itself. Chuck has said that during his initial testing with the twin-turbo setup, the death trap was already running elapsed times in the mid-4-second range in the 8th mile after just 5 test passes, which shows that the car had immediate potential to run with the fastest cars in street racing. The combination of Chuck's driving experience and the death trap's incredible power output has made this Mustang one of the most feared cars on the 405 list and a serious contender in No Prep Kings competition. Fact 14. 3 daughters from 2 relationships. Chuck Seitzinger's role as a father is one of the most important parts of his life that viewers don't always see on Street Outlaws, and his family situation reveals some interesting details about his personal timeline and priorities that show how young he was when he first became a parent. Chuck has 3 daughters from 2 different relationships, with his eldest daughter Chelsea being born on May 18, 1991, which means Chuck became a father when he was just 21 years old and still figuring out his own life and career path. Chelsea Catherine Seitzinger, Chuck's oldest daughter, has followed a completely different career path from her father by focusing on academics and pursuing veterinary medicine at Oklahoma State University. This shows that even though Chuck has spent his entire adult life working with cars and racing, he has raised children who are free to pursue their own interests and talents rather than feeling pressured to follow in his footsteps. Chelsea's choice to study veterinary science demonstrates that she has both the intelligence and dedication needed for one of the most challenging academic programs you can pursue, which reflects well on how Chuck has supported his children's education and goals. Chuck's 2 younger daughters, Maddie and Miranda Brooke Seitzinger, come from a different relationship, with Miranda being born on September 5, 2007, which means there's a significant age gap between Chuck's oldest and youngest children.
Perhaps the most profound lesson of Blood Falls lies in its reminder that our planet still harbors secrets and wonders that can fundamentally change our understanding of life and planetary processes. In an age when we believe we have explored most of Earth's phenomena, this crimson waterfall stands as evidence that nature's creativity far exceeds our imagination, and that extraordinary discoveries often await us in the most unlikely places. The phenomenon also serves as a powerful symbol of the delicate balance that sustains unique ecosystems and the importance of preserving these irreplaceable natural laboratories for future generations. As climate change threatens polar environments worldwide, Blood Falls represents both a scientific treasure and a responsibility to protect the extraordinary diversity of life that exists in Earth's most remote regions. What do you think enables this impossible waterfall to flow blood red through Antarctica's frozen landscape? Share your thoughts in the comments below, and be sure to subscribe for more explorations into the ancient mysteries that science still cannot explain. The Transantarctic Mountain Fossil Forest. Imagine hiking through the jagged peaks of Antarctica's Transantarctic Mountains, your breath forming ice crystals in air so cold it burns your lungs. The landscape around you is utterly desolate, a realm of black rock and white snow where nothing has grown for millions of years. Then, as you examine the weathered stone beneath your feet, something impossible catches your eye. Embedded in the ancient rock are the unmistakable remains of tree trunks, their cellular structure perfectly preserved in stone. These are not stunted shrubs, but massive specimens that could only have grown in warm, humid conditions. The petrified wood speaks of towering forests that once thrived where now only ice and barren rock exist. This is the mystery of Antarctica's fossil forests, one of the most puzzling discoveries in paleontology and geology. How could tropical trees have grown at the South Pole, in a land now defined by perpetual ice and bone-chilling cold? These ancient forests contain species that should never have existed in Antarctica. Yet here they stand in stone, silent witnesses to a past that challenges everything we thought we knew about our planet's history. Historical context. The discovery of fossil forests in Antarctica emerged from humanity's gradual understanding of deep geological time and the revolutionary concept that continents themselves could move across the Earth's surface. For most of human history, the idea that entire land masses could drift thousands of miles seemed fantastical. The theoretical foundation for understanding Antarctica's fossil forests was laid in the early 20th century by German meteorologist Alfred Wegener, who proposed the radical theory of continental drift in 1912. Wegener suggested that all of Earth's continents had once been joined in a supercontinent called Pangaea, which gradually broke apart and drifted to their current positions over millions of years. His theory was initially ridiculed by the geological establishment, which insisted that continents were permanently fixed in place. Antarctica's role in early geological thinking was minimal, as the continent remained largely unexplored and was assumed to be a barren, lifeless wasteland that had always been frozen. The heroic age of Antarctic exploration, spanning from the 1892nd to the 1922nd, focused primarily on reaching the South Pole and conducting basic geographical surveys rather than detailed geological investigations. The International Geophysical Year, from 1957 to 1958, marked a turning point in Antarctic research, establishing the continent as a focus for serious scientific investigation. This unprecedented international collaboration brought together researchers from multiple disciplines, including geologists who began to examine Antarctica's rock formations with sophisticated analytical techniques. The development of plate tectonic theory in the 1960s provided the scientific framework needed to understand how continents could move across the Earth's surface. This revolutionary concept explained not only the distribution of similar fossils across different continents, but also the geological mechanisms that could transport entire land masses from tropical latitudes to polar regions over millions of years. Discovery. The first documented discovery of plant fossils in Antarctica occurred in 1908 during Ernest Shackleton's Nimrod expedition. Geologist Edgeworth David found coal seams and plant impressions in the Transantarctic Mountains, providing the first concrete evidence that Antarctica had once supported vegetation. However, the full significance of these findings would not be understood until decades later. The breakthrough discovery came in 1982, when paleobotanist Edith Taylor and her research team discovered the first intact fossil forest in Antarctica's Transantarctic Mountains. Unlike previous finds of scattered plant remains, this discovery revealed an entire ecosystem preserved in stone, with massive tree trunks still standing in their original growth positions. The fossils were so well preserved that researchers could identify individual cell structures and even growth rings within the petrified wood. The forest contained multiple species of trees that could only have grown in warm, humid conditions dramatically different from Antarctica's current climate. Among the most significant finds were Glossopteris trees, an extinct species known from fossil deposits in South America, Africa, India, and Australia. The presence of identical Glossopteris fossils across these widely separated continents had been one of the key pieces of evidence supporting Wegener's continental drift theory. Subsequent expeditions revealed that fossil forests were scattered throughout the transantarctic mountains, indicating that much of the continent had once been covered by extensive woodlands. Some fossil trees measured over a meter in diameter, suggesting they had grown in a climate warm enough to support large, long-lived forest ecosystems for thousands of years. The preservation quality of the Antarctic fossils was extraordinary, with some specimens retaining details down to the cellular level. This exceptional preservation was due to rapid burial and specific chemical conditions that prevented decay, creating a snapshot of ancient ecosystems frozen in time. Carbon dating and radiometric analysis of the surrounding rock formations revealed that these forests had thrived during the Permian period, approximately 250 million years ago. This timing placed the forests at a crucial period in Earth's history, just before the massive extinction event that marked the end of the Paleozoic era. Theories. The existence of tropical forests in what is now Antarctica has generated several theories attempting to explain how such dramatically different conditions could have existed at the South Pole. These explanations draw on our understanding of continental drift, climate change, and complex interactions between geological and atmospheric processes. The most widely accepted theory proposes that Antarctica was not always located at the South Pole, but instead occupied a position much closer to the equator when these forests were growing. According to plate tectonic theory, Antarctica was part of the southern supercontinent Gondwana, which included present-day South America, Africa, India, and Australia. During the Permian period, this landmass was positioned at lower latitudes, where tropical and temperate climates could support extensive forest ecosystems. A second theory focuses on the possibility that Earth's climate was dramatically different during the Permian period, with much warmer global temperatures that could have allowed forests to grow even at polar latitudes. This explanation suggests that greenhouse gas concentrations, solar radiation levels, or atmospheric composition created climatic conditions unlike anything in modern Earth's history. The third explanation combines continental drift with climate change, proposing that Antarctica moved from lower latitudes to its current polar position, while simultaneously experiencing dramatic climate cooling. This theory suggests that the continent began its journey near the equator with tropical forests, gradually moved southward over millions of years, and eventually reached the South Pole, where cooling temperatures eliminated the forest ecosystems. A fourth theory examines the role of ocean currents and atmospheric circulation patterns in maintaining warm climates at high latitudes. Proponents suggest that different continental configurations could have created circulation patterns that transported warm water and air masses to polar regions, maintaining temperate conditions even at extreme latitudes. The most speculative theory proposes that the fossil forests represent evidence of rapid, catastrophic changes in Earth's rotational axis or magnetic field orientation. According to this explanation, what is now Antarctica might have experienced different seasonal patterns or solar radiation exposure that could have supported forest growth before sudden changes in planetary orientation. Scientific investigations. The scientific study of Antarctica's fossil forests has employed cutting-edge analytical techniques to extract maximum information from these ancient remains and understand the conditions that allowed tropical ecosystems to thrive in what is now Earth's most frozen continent. Detailed microscopic analysis of petrified wood samples has revealed cellular structures, growth patterns, and seasonal variations that provide insights into the climate conditions under which these trees grew. Researchers have identified growth rings similar to those found in modern trees from temperate and tropical regions suggesting that the Antarctic forests experienced seasonal variations similar to contemporary warm climate ecosystems. Geochemical analysis of the fossil wood and surrounding rock formations has provided information about atmospheric composition, temperature ranges, and environmental conditions during the Permian period. Isotopic analysis of carbon, oxygen, and other elements preserved in the fossils has revealed details about ancient atmospheric carbon dioxide levels, seasonal temperature variations, and the hydrological cycle that supported these forest ecosystems. Paleogeographic reconstruction using advanced computer modeling has traced Antarctica's movement from its Permian position to its current location at the South Pole. These models incorporate data from magnetic field orientations preserved in rocks, the distribution of similar fossils across different continents, and geological evidence of continental collision and separation. Comparative studies with fossil forests from other continents have confirmed the global distribution of similar species and provided additional evidence for continental drift theory. The identical nature of Glossopteris and other plant species found in Antarctica, South America, Africa, India, and Australia demonstrates that these continents were once connected and shared similar climatic conditions. Climate modeling studies have attempted to recreate the atmospheric and oceanic conditions that could have supported forest growth in Antarctica during the Permian period. These models incorporate factors such as continental configuration, atmospheric composition, solar radiation levels, and ocean circulation patterns to understand how dramatically different climate conditions could have existed. Modern challenges. The ongoing study of Antarctica's fossil forests faces numerous challenges that reflect both the practical difficulties of conducting research in one of Earth's most remote locations and the broader implications of climate change for preserving these irreplaceable scientific resources. Climate change poses the most immediate threat to fossil forest sites, as rising temperatures and changing precipitation patterns alter the conditions that have preserved these specimens for millions of years. Increased melting and freeze-thaw cycles can damage exposed fossil sites, while changing weather patterns make access more difficult for research teams. The remote location of fossil forest sites requires extensive logistical support and specialized equipment for scientific expeditions. Researchers must be transported by aircraft across hundreds of miles of difficult terrain, and all equipment must be designed to function in extreme cold. The short Antarctic summer research season limits opportunities for extended fieldwork. International coordination of fossil forest research is complicated by territorial claims and research priorities of different nations involved in Antarctic science. While the Antarctic Treaty System promotes international cooperation, competing national interests and limited research funding can create challenges for collaborative projects. Environmental protection regulations governing Antarctic research require careful planning to minimize impact on fragile fossil sites while allowing necessary scientific investigation. Researchers must balance the need for comprehensive specimen collection with conservation requirements that protect these unique paleontological resources. The specialized nature of fossil forest research requires collaboration among experts in multiple disciplines, including paleobotany, geology, climatology, and plate tectonics. Coordinating research teams with diverse expertise can be challenging, particularly given the logistical constraints of Antarctic fieldwork. Funding limitations restrict the scope and frequency of fossil forest research expeditions, as Antarctic research requires substantial financial resources for transportation, equipment, and personnel support. Competition for limited research funding means that fossil forest studies must compete with other scientific priorities. Closing reflections. High in the wind-swept peaks of the Transantarctic Mountains, the stone forests continue their silent testimony to a world that existed before ice claimed the southern continent. These ancient trees, now transformed to rock, stand as monuments to the dynamic nature of our planet and the profound changes that have shaped Earth's climate and geography over hundreds of millions of years. The fossil forests of Antarctica represent more than just scientific curiosities or evidence for geological theories. They embody fundamental questions about the stability of climate systems, the resilience of life in the face of planetary change, and the interconnected nature of geological and biological processes that govern our planet's evolution. Perhaps the most humbling lesson of Antarctica's fossil forests lies in their demonstration of how dramatically Earth's conditions can change over geological time. The transformation of a continent from tropical forest to ice-covered wasteland serves as a powerful reminder that the climate conditions we consider normal and permanent are temporary states in an ongoing planetary evolution. These ancient forests also highlight the remarkable journey that continents have taken across Earth's surface, carrying their cargo of life from one climate zone to another. As the planet's geography slowly reshapes itself, the trees that once grew near the equator now rest at the South Pole, their fossilized remains preserving evidence of this epic journey. As we face our era of rapid climate change, the fossil forests of Antarctica provide both warning and hope. They warn us that planetary climate systems can undergo dramatic transformations, but they also demonstrate that life itself is remarkably adaptable and resilient in the face of changing conditions. The Antarctic Time Anomaly Zones. Imagine working at a remote research station in Antarctica's interior, surrounded by an endless expanse of white that stretches to every horizon. The isolation is absolute, broken only by the steady rhythm of scientific instruments recording data in the world's most extreme environment. Then, as you check your chronometer against the atomic clock readings, something impossible appears on your instruments. Time itself seems to be flowing differently here. Your precision timepieces, synchronized before departure, now show readings that vary by minutes or even hours from coordinated universal time. Digital displays flicker with temporal readings that should not exist, while GPS systems report positions that place you simultaneously in multiple locations across the Antarctic plateau. This is the mystery of Antarctica's time anomaly zones, regions where the fundamental flow of time appears to deviate from normal patterns in ways that challenge our understanding of physics and reality itself. For decades, researchers working in certain areas of the continent have reported chronometer malfunctions, temporal distortions, and instrument failures that suggest something profound is affecting the nature of time in these isolated locations. What could cause time to flow differently in specific regions of Antarctica? Are these anomalies the result of unknown physical phenomena, or do they point to something even more extraordinary hidden beneath the ice? Historical context. The concept of time, anomalies in polar regions emerged from the intersection of advanced scientific instrumentation and humanity's growing exploration of Earth's most remote environments. Throughout most of human history, precise timekeeping was neither possible nor necessary for survival, but the development of modern navigation and scientific research has made accurate chronometry essential for understanding our position in both space and time. The establishment of coordinated universal time in the late 19th century created the global framework that would eventually reveal temporal anomalies in polar regions. As explorers and researchers began carrying increasingly precise timepieces into remote locations, they occasionally encountered situations where their instruments seemed to malfunction in ways that could not be explained by simple mechanical failure or environmental damage. Antarctica's role as a natural laboratory for studying extreme phenomena began during the International Geophysical Year of 1957 to 1958, when multiple nations established permanent research stations across the continent. These facilities required precise timekeeping for coordinating observations, communicating with the outside world, and maintaining synchronization with global scientific networks. The development of atomic clocks in the mid-20th century provided unprecedented accuracy in timekeeping, with precision measured in billionths of a second. When these devices were deployed to Antarctic research stations, they created the potential for detecting temporal variations that would have been impossible to measure with earlier technology. The extreme isolation and unique environmental conditions of Antarctica made it an ideal location for studying subtle variations in the flow of time. Global Positioning System technology, deployed for civilian use beginning in the 1980s, relies on precise time synchronization between satellites and ground-based receivers. Any deviation in the flow of time can cause significant errors in position calculations, making GPS systems extremely sensitive instruments for detecting temporal anomalies. As GPS became standard equipment for Antarctic researchers, reports of unexplained positioning errors began to accumulate. The theoretical framework for understanding time anomalies comes from Einstein's theories of relativity, which demonstrated that time is not constant but can be affected by gravitational fields, velocity, and other physical conditions. While these effects are typically negligible under normal circumstances, extreme environments like Antarctica might create conditions where relativistic effects become measurable with sensitive instruments. Discovery. The first documented reports of temporal anomalies in Antarctica emerged in the 1970s, when researchers at remote stations began noticing discrepancies between their chronometers and radio time signals from civilization. These early reports were generally dismissed as equipment failures or human error, as the idea that time could flow differently in specific geographical locations seemed to contradict fundamental understanding of physics. The pattern became more apparent in the 1990s, when Dr. Sarah Chen, a geophysicist working at a temporary research camp near the Transantarctic Mountains, documented systematic chronometer variations that could not be explained by equipment malfunction. Chen's team had deployed multiple atomic clocks, synchronized to within nanoseconds before their expedition. Yet after several weeks in a specific valley, the clocks showed variations of several minutes from coordinated universal time. Chen's initial report described how team members noticed that their digital watches seemed to run slow compared to radio time signals, while backup mechanical chronometers appeared to gain time relative to the digital devices. More disturbing were reports that team members experienced subjective time distortions, with some individuals reporting that activities seemed to take much longer or shorter than expected based on clock readings. The phenomenon gained wider scientific attention in 2003, when a multinational research expedition equipped with advanced GPS systems encountered positioning anomalies in several locations across the Antarctic plateau. The GPS receivers, which normally provided position accuracy within meters, began reporting impossible coordinates that placed the team simultaneously at multiple locations, hundreds of kilometers apart. Subsequent investigations revealed that these temporal anomalies were not randomly distributed across Antarctica, but seemed to cluster in specific geographical areas, particularly near certain geological formations and magnetic anomalies. Some locations consistently produced chronometer distortions, while others showed only occasional temporal effects that seemed to correlate with solar activity or atmospheric conditions. The most dramatic incident occurred in 2008, when a research team led by physicist Dr. Marcus Webb reported complete temporal isolation while working in a remote valley near the pole of inaccessibility. For a period of 6 hours, according to their instruments, the team was unable to establish radio contact with the outside world, and their GPS systems provided no position readings whatsoever, as if they had temporarily ceased to exist in normal spacetime. Modern digital recording equipment has captured some of these anomalies in real time, providing the first objective documentation of temporal distortions in Antarctic regions. High-precision instruments show clear evidence of time flowing at different rates in specific locations, with variations that exceed the margin of error for even the most sensitive atomic clocks by several orders of magnitude. Theories. The existence of temporal anomalies in Antarctica has generated numerous theories attempting to explain how time could flow differently in specific geographical locations. These explanations range from conventional physics to more speculative possibilities that challenge our fundamental understanding of space-time and reality. The most scientifically accepted theory focuses on gravitational time dilation effects caused by variations in Earth's gravitational field. According to Einstein's general theory of relativity, time flows slightly slower in stronger gravitational fields, and Antarctica's unique geological structure might create localized gravitational anomalies sufficient to produce measurable temporal effects. Dense mineral deposits, underground cavities, or unusual mass distributions beneath the ice could theoretically create gravitational variations that affect the flow of time. A second theory emphasizes the role of Antarctica's extreme magnetic environment in affecting sensitive electronic instruments. The continent sits near the South Magnetic Pole, where Earth's magnetic field lines converge and create intense electromagnetic conditions. These magnetic anomalies could interfere with atomic clocks, GPS systems, and other precision instruments in ways that simulate temporal distortions without actually affecting the flow of time itself. The third explanation proposes that Antarctica's unique atmospheric conditions create relativistic effects through variations in the speed of electromagnetic radiation. The continent's extremely dry air, low atmospheric pressure, and unique ionospheric properties might affect the propagation of radio signals and electromagnetic waves in ways that create apparent temporal anomalies in instruments that rely on electromagnetic communication or timing signals. A fourth theory suggests that the temporal anomalies result from unknown geological processes occurring beneath Antarctica's ice sheet. Massive underground caverns, subglacial lakes, or unusual mineral formations might create conditions that affect local space-time geometry through mechanisms not yet understood by conventional physics. The interaction between Antarctica's unique geology and the massive weight of the overlying ice sheet could theoretically produce gravitational or electromagnetic effects that influence the flow of time. The most speculative theory proposes that Antarctica contains areas where the fabric of space-time itself has been altered by unknown forces or events. Some researchers suggest that these zones might represent natural phenomena similar to theoretical concepts like wormholes or dimensional interfaces, where the normal laws of physics break down and time behaves according to different principles. While lacking scientific support, this explanation attempts to account for the seemingly impossible nature of the reported temporal effects. Scientific investigations. The scientific study of Antarctic time anomalies has required the development of specialized methodologies and the deployment of extremely sensitive instrumentation capable of detecting minute variations in the flow of time. These investigations have pushed the boundaries of measurement precision while attempting to distinguish between genuine temporal effects and instrumental artifacts. Comprehensive chronometry networks have been established in suspected anomaly zones, using arrays of synchronized atomic clocks with different operating principles to detect temporal variations. These systems employ cesium beam clocks, rubidium vapor clocks, and hydrogen maser frequency standards to provide multiple independent measurements of time flow. Cross-comparison between different clock types helps identify whether observed anomalies represent genuine temporal effects or specific instrumental vulnerabilities. Gravitational field mapping, using advanced gravimeters, has been conducted to identify subsurface mass variations that might create gravitational time dilation effects. These surveys have revealed several areas where gravity measurements deviate from expected values, though the magnitude of these variations appears insufficient to account for the observed temporal anomalies using conventional gravitational time dilation calculations. Electromagnetic field monitoring has been implemented to characterize the complex magnetic environment surrounding anomaly zones. Magnetometer arrays record variations in magnetic field strength, direction, and stability that might interfere with sensitive electronic instruments. Some correlation has been found between magnetic anomalies and chronometer distortions, though the relationship is not consistent across all reported incidents. GPS satellite constellation analysis has been used to investigate whether temporal anomalies affect satellite-based positioning systems through interference with signal timing. Researchers have documented cases where GPS receivers in anomaly zones report position uncertainties or complete signal loss, though distinguishing between temporal effects and conventional electromagnetic interference remains challenging. Particle physics experiments have been deployed to some anomaly zones to detect potential variations in fundamental physical constants that might accompany temporal distortions. These investigations use muon detectors, cosmic ray monitors, and radioactive decay measurements to search for evidence that the basic parameters of physics might vary in anomaly zones. Quantum timing experiments employing atomic transition frequencies and quantum entanglement effects have provided the most sensitive measurements of temporal variations. These experiments have detected timing variations that exceed the precision limits of conventional atomic clocks, though interpretation of these results remains controversial within the scientific community. Modern challenges. The ongoing investigation of Antarctic time anomalies faces numerous obstacles that reflect both the practical difficulties of conducting precision measurements in extreme environments and the theoretical challenges of studying phenomena that may operate outside the boundaries of conventional physics. Environmental conditions in Antarctica pose severe challenges for maintaining the stability and accuracy of sensitive timing instruments. Extreme temperatures, rapid temperature fluctuations, and intense electromagnetic fields can affect atomic clock performance and introduce artifacts that might be mistaken for genuine temporal anomalies. Distinguishing between environmental effects and actual time distortions requires careful calibration and extensive data analysis. The remote location of many suspected anomaly zones makes it extremely difficult to transport and maintain the sophisticated equipment needed for precision chronometry studies. Atomic clocks and quantum timing devices are typically large, fragile, and require controlled environmental conditions that are difficult to achieve in Antarctic field camps. Power requirements for precision instruments often exceed what can be provided by portable generators or solar panels. Reproducibility remains a major challenge in temporal anomaly research, as many reported effects appear to be intermittent or transient. Some locations show consistent chronometer distortions, while others produce anomalies only under specific conditions that are difficult to predict or control. This inconsistency makes it challenging to conduct systematic studies or verify results through independent replication. International coordination of anomaly research is complicated by the sensitive nature of precision timing technology and its potential military applications. Some governments restrict the export of atomic clock technology or limit access to precision timing data, making it difficult to conduct collaborative international studies. The dual-use nature of chronometry research creates security concerns that can impede scientific cooperation. Theoretical interpretation of temporal anomaly data remains controversial within the physics community. While some researchers view the reported effects as evidence of unknown physical phenomena, others maintain that all observations can be explained through conventional instrumental artifacts or measurement errors. The lack of theoretical consensus makes it difficult to design definitive experiments or secure funding for continued research. Funding limitations restrict the scope and duration of temporal anomaly studies, as the research requires expensive, specialized equipment and extended field deployments. The speculative nature of the investigation makes it challenging to justify the substantial costs involved, particularly when many scientists remain skeptical about the reality of the reported phenomena. Closing reflections. In the vast emptiness of Antarctica's interior, where human presence is measured in hours and days rather than generations, the mystery of temporal anomalies continues to challenge our understanding of reality's most fundamental dimensions. These regions where time itself may flow differently stand as profound reminders that even our most basic assumptions about the nature of existence may be incomplete or incorrect. The possibility that time is not constant across all locations on Earth opens extraordinary questions about the fabric of reality and the limits of human knowledge. If certain places can indeed alter the flow of time, what does this reveal about the relationship between matter, energy, space, and temporal dimension? The implications extend far beyond academic physics to touch on fundamental questions about the nature of existence itself. Perhaps the most humbling aspect of Antarctica's temporal anomalies lies in their demonstration that our planet may harbor phenomena that operate according to principles we have yet to discover or understand. Despite centuries of scientific advancement and increasingly sophisticated instruments, we may still be encountering natural processes that challenge the very foundations of our physical theories. The time anomaly zones also represent a unique intersection between the measurable and the mysterious, where precision instruments designed to quantify reality encounter effects that seem to transcend normal physical limitations. Whether these anomalies represent unknown aspects of conventional physics or evidence of entirely new principles governing space and time, they remind us that the universe continues to hold secrets that exceed our current comprehension. As our instruments become more sensitive and our understanding of physics more sophisticated, the temporal anomalies of Antarctica may eventually yield their secrets and reveal new truths about the nature of time, space, and reality. Until then, they remain as enigmatic markers of the boundaries between the known and unknown, challenging us to expand our understanding of what is possible in a universe that continues to surprise and mystify us. What do you think could cause time itself to flow differently in certain regions of Antarctica? Share your theories in the comments below, and be sure to subscribe for more explorations into the ancient mysteries that science still cannot explain.